everyone. Good evening again. My name is Ankit Dongriyal, your mentor from Civil Engineering Department. I again welcome you on this YouTube platform of IMS GATE Academy. As in the last class, we have already discussed about the part 1 of your geotechnical engineering. In this particular session, I am going to cover the rest of the part which was left for the last class, right? Yeah, good evening, Rakesh. All the students, just make your presence in the chat box. All the students who are in the live class, just show your presence by your comments and likes. Okay, hi Chandu, good evening. Good evening to all. Right, so in the last class, we have already covered about the three-phase system of the soil. We know that the soil is having a three-phase system. It consists of solids, it consists of water and air. And the constituents of all these, it is going to affect the properties of soil, right? Based on that, yeah, hi Rahul. And based on that, we have discussed that there are different index properties, those properties which are used for the classification of your soil, right? And after that, we have seen the classification of your coarse-grained soil and fine-grained soil. After that, we have discussed about the effective stress theory. We have seen that how effective stress is going to change when there will be fluctuation in water table. What will be the change with the capillary effect? What will be the change with super or your surcharge load, right? After that, we have discussed about the seepage theory. We have discussed that what is permeability, right? And when there is a flow of water, there will be a seepage pressure acting on the solids by that particular water. We have discussed about the upward seepage flow and downward seepage flow. Clear? In upward seepage flow, one special condition also we have discussed, that was your quicksand condition, that we also call it as a piping or sand boiling. So up to this particular point we have covered in the last class. Our today's agenda will be first to cover our stresses in soil, compaction and consolidation, right? So this will be our first topic, that will cover about the stresses in soil, compaction and consolidation. Now out of this particular topic, this consolidation is very much important. This consolidation, it is very much important for your exam. You are going to definitely get one question in your GATE 2023 from this particular topic. Clear? Yeah, hi Sandeep sir. Okay, right. So we'll just move to the next part. If we talk about the stresses in soil, what we have studied in the effective stress? Yeah, what we have studied in the effective stress, in effective stress chapter, we have studied that what will be the stress at any particular depth due to the weight of soil and any particular surcharge load, right? But now the stresses in soil, again we are studying this particular topic. Why? As in this particular topic, now we are going to discuss about what will be the stresses at any particular depth. Yeah, your Bosniewski theory will be enough, that I'll explain, right? Right. So stresses in soil, we are discussing here that if there is any superstructure load, as this particular load is important for you, right? As when you are going to construct any particular building, any superstructure over your soil, that particular building, it is going to transfer some load to your soil, right? Now, how much stresses will get generated due to the superstructure load, that we are going to see in this particular stresses in soil. Clear? It will be just a revision type of video. Other than that, we are mainly having focus on the questions, right? So we know that in our syllabus there is only Basinescu's theory now. This Westergaard theory is not in our syllabus mentioned by the IITs, right? So what is the stress? Let's suppose there is a particular load at this particular point, right? Or try to understand it first. Let's suppose, if I explain you in the 3D, let's suppose there is any particular load P at this point, right? And you need to find out the stress value somewhere here. You need to find out the stress value somewhere here. So first you have to reach this particular point. How you can reach? Just first you move the in x-axis, then in this particular y-axis, and finally in the z-axis, right? If I take this as a x-axis, this is your y-axis, and downward, that is your z-axis. Clear? So it means now if I take this particular I am saying it as a r, that is the radial distance. Clear? So this is particularly a 3D problem. We have converted this particular 3D problem into 2D problem by just taking this plane. By just taking this plane, r and z plane. So this is here your r and z plane. This is the value of r in this particular direction, and this is the value of z in this particular direction. Right? So whenever you see this particular diagram, this is nothing but it is here in the RZ plane. This particular 3D problem we have converted it to 2D problem. Clear? What will be this R value? If in a particular question X and Y is given to you, you know that this is particularly a 90-degree angle. So your R is going to be what? Your R is going to be under root of X square plus Y square. Clear? Sometime it may happen that it will give you the X, Y and Z coordinate. So from there also you can find out what will be our R coordinate. So whenever you see this particular diagram, it is in this RZ plane. Clear? Now we want to see that if there is any particular load at this point, what will be the stress value at a point which is at a radial distance r from here and at a z depth from here and at a z depth. Clear? So the stress value due to this particular point load, it is given by P upon Z square, that is load value divided by depth square into Boston-Hughes factor, right? Boston-Hughes impact factor, and this Boston-Hughes impact factor IB, it is given as, if it is not properly visible, I'll write it again. It is 3 upon 2 pi 1 upon 1 plus r by z whole square whole to the power 5 by 2. Whole to the power 5 by 2, right? This is your IB value. If you multiply it with load divided by this depth square, it is going to give you the stress value at this particular point. Clear? Yeah. Right? Now, if you need to find out, sometime it may ask for the shear stress value. This was the normal stress. Sometime it may ask for the shear stress value. Your shear stress value, it will be normal stress at any particular r by z value multiplied by r by z. Clear? So this will be the shear stress at that particular point. That will be the shear stress at that particular point. Other than that, there can be different type of loading. The formulas to those are given in your particular notes also, right? So there is particularly a formula based questions only. Now our main point of this particular topic is your consolidation in soil, right? So what is your consolidation of soil? When there is a superstructure load, due to that there will be generation of stresses, right? Yeah, we will solve the problems, right? Definitely we are going to solve the problems. Just I'll give you an insight of 5 minutes. After that we are going to see the questions only. Clear? So if I discuss about the consolidation of soil, we know that when there is a superstructure load, due to that particular stress value, there will be expulsion of pore water. There will be expulsion of pore water from the voids of the soil. Yeah, hi Assis, from the voids of the soil. Due to that particular stress value or due to this expulsion of pore water, there will be change in volume, right? Or there will be decrease in volume of soil. This particular change in volume or decrease in volume, we call it as a consolidation, right? So generally we have two types of consolidation, that is primary consolidation and secondary consolidation. Your primary consolidation, it is mainly due to the expulsion of pore water. Clear? There is also one secondary consolidation. Mainly you will find it in the clay soil or plastic soil. That is your mainly due to the readjustment of soil particles, right? Or plastic readjustment of the particles. Clear? But mainly if we talk about the Terzaghi theory is the most important theory in this particular course, right? So if we talk about the Terzaghi's theory, right? Or Terzaghi has given one spring analogy method just to understand this particular process, and according to him, this consolidation process, you can represent it with a differential equation, that is del u by del t, it will be is equal to Cv into del square u by del z square, right? So change in the pore water pressure with time, it can also be understood with the help of this consolidation process. You can you can understand that process with the help of that how your pore water pressure is changing with time. Clear? As when you'll apply the load, first that particular load, it will be taken by whom? It will be taken by water. Now with the time, when this water will get path to expel from the soil, due to this particular expulsion of pore water, your excess pore water pressure is going to reduce, and that pressure now it will be transferred to the solids. Due to that particular, your solids is going to get compacted, right, and your voids are going to get reduced. Clear? And this particular reduction in voids, reduction in volume, you call it as a compressibility, or here as it is due to the expulsion of pore water, you will call it as a consolidation. Clear? So this is the particular Terzaghi's equation, right? Now the solution of this Terzaghi's equation, if we talk about this particular equation solution, one of the solution is your degree of consolidation, that is your degree of consolidation, right, mainly represented by U. What this degree of consolidation suggests? This degree of consolidation is, it is the how much proportion of total consolidation, how much proportion of the total consolidation it get completed at any particular instant of time, it will be given by this degree of consolidation, right? So degree of consolidation, we can say it is whatever is the consolidation at any particular time h, whatever is the particular consolidation at any particular time h divided by total consolidation, or sometimes you call it as a total settlement. Clear? If I represent it in percentage, you can multiply it with 100. In terms of void ratio also we can explain this, right? There will be reduction in the void ratio, like that also you can explain this, or you can also explain it with the reduction in the pore water pressure. Like initially, let's suppose UI is your initial pore water pressure, right? At any particular time, now the pore water pressure reduces from initial value to this UT value. Clear? How much will be the total reduction? It will be from initial value to 0. When the pore water pressure, excess pore water pressure will become 0, it means at that particular point your consolidation process get completed, right? So like this also, sometimes you represent this degree of consolidation. Clear? Now we will talk about mainly the type of question which can be asked from this particular chapter. What mainly examiner asks you in this particular chapter? There are two type of question which can be asked. First is, if the settlement value is given to you at any particular time, if settlement value is given to you, it will ask you that how much time it will be required for this particular settlement value. Clear? Like it will ask you that, okay, there is a 25 mm of settlement, it will give you the properties of soil, it will give you that okay, there is a 25 mm of settlement, and it will ask that how much time it will require, for this particular settlement value. This is one type of question. Second type of question is, it will give you the time. Let's suppose it has given you the time as 3 years. It has given you the time as 3 years, and it will ask you that in these 3 years, how much settlement will be there? How much settlement will be there? Clear? So these are the two type of questions which are generally asked in your exam. How to process this type of questions? Now try to see. If delta H is given to me, right? I'm assuming that total settlement is also known to me. I can find out what is my degree of consolidation. That is delta H upon capital delta H into 100, if I am taking it in percentage. Right? Now, this degree of consolidation, it is related with the time factor, right? So time factor is the quantity which relate degree of consolidation, or which relate this settlement value with time, right? Now, your TV is equal to pi by 4 of U square. Clear? What is this U? U is your degree of consolidation. Here this U is in decimals, right? Remember that here the U is in decimal, right? This particular formula, it is valid when your U is less than 60%. When your U is less than 60%. If your U is greater than 60%, your TV value will be 1.78 minus 0.9332 log base 10 100 minus U. Here you have to use the U in percentage. This U is now in percentage. Clear? So remember this particular formula also. Right. Now, once U is known to you, you can find out the TV value. Once TV value is known to you, now this TV also connect you with this particular time. Now, TV, we have another formula that TV is equal to CV into T by D square. CV into T by D square. From here you can find out this particular T value. Clear? What is this CV value here? What is this D value here? Here CV, it is your coefficient of consolidation. Coefficient of consolidation. Right? What is this D? D is your length of drainage path. D is your length of drainage path. Clear? Sir, what is this length of drainage path? It is the particular distance, or it is the maximum distance which a water molecule has to travel before expelling out from the clay layer. Why I am saying clay layer? As we generally focus about the consolidation of your clay layer only, right, or clay soil only. As when there is a construction, that particular coarse grained soil, that is your sand, it is having a greater permeability, right? Your permeability of coarse grained soil is more, that is in sand. So whatever is the consolidation, whatever will be the consolidation in your coarse grained soil, it will be done during the construction period of your building only. Now for us, what is more important? Let's suppose we have constructed one building, right? Today we have constructed one building, and after 3 or 4 years, if my soil below our foundation, it is going to get settled. That is the mainly problem for us, right? For a civil engineer, that is mainly the problem. We know that the settlement of sand, it will be completed within construction period only. It means the problematic soil for us from the consolidation point of view is clay. So that's why we mainly take into account the consolidation of clay only, right? Now, this is the particular process. If settlement is given to you, how to find out what will be the time required? If time is given to you, this particular process you can repeat in this particular cycle, right? So remember this particular cycle. You can also take the screenshot if you want, right? Okay. Okay, so this is one particular type of question. Second type of question which can be asked to you is settlement. Which can be asked to you is to find out the settlement in the soil. As we know that consolidation is nothing but the change in the volume. This particular change in volume we generally take into account with change in depth only. As we know that the soil is semi-infinite material, it is having an infinite area, right? So whatever is the change in volume, we take into account that in the case of, or in the terms of depth only, right? So if I am saying that there is a change in depth, that is the consolidation, I can say that it is also a settlement value, right? So we are more focused about the consolidation settlement, right? Now there are mainly the 3 formulas by which you can find out the consolidation. All the formulas are correlated. If this particular formula is known to you, you can derive all other formulas also, right? So what is your first formula? Your first formula is delta H. Delta H is your total settlement. Remember, this is your ultimate settlement value. So your ultimate settlement upon thickness of compressible layer, it is given as delta E, change in void ratio upon 1 plus E naught. Clear? Second formula is your settlement value. It is nothing but thickness of compressible layer into MV. MV is your coefficient of volume compressibility into change in effective stress. Now this is the particular term which is important for you. All other terms you might be knowing. This is your coefficient of volume compressibility. The formula for this is MV is equal to there nothing but it is your AV upon 1 plus E naught, right? And what is this AV? This AV, it is your coefficient of compressibility, which is nothing but the slope of your void ratio versus effective stress graph. Void ratio versus effective stress graph. Clear? So this is nothing but change in void ratio with change in effective stress. When the stress value will increase, obviously there will be decrease in the void ratio, that is given by that particular graph slope. It is given by this particular term, that is your coefficient of compressibility. Clear? So these are the some coefficient which are used in this particular chapter. Now this sigma bar, delta sigma bar, this is the particular important term for you, right? Now try to understand. Let's suppose this is your particularly foundation, right? And there will be a load from the superstructure. Now due to this particular load, you need to find out that what will be the settlement of this clay layer. Above here it is sand, below also it is sand. Above here it is sand, below also it is sand, right? So we need to find out what will be the consolidation settlement in this particular clay layer. This is your clay. This is your clay, right? So the stress value which we calculate, these are calculated at the center of this compressible layer. As we know that the stress value, it is also the factor of depth. It is also the factor of depth. So sir, where I have to take the stress? At this particular point or at this particular point, right? At this particular point is also clay, at this particular point is also clay. So if I am moving downward, definitely there will be change in stress. From our effective stress chapter also we have seen that the stress at any particular depth, it is given by gamma, that is unit weight of that particular material divided by depth of that material. So what we consider, we take the stress value at the center of this compressible layer, right? So where we calculate these stresses? At the center of the compressible layer. Clear? So whatever is this delta sigma bar, this delta sigma bar is the change in stress value. This sigma bar is change in stress value. It means there will be initially some stress, after that there is some change. Now try to understand it. Let's suppose there is no foundation. Let's suppose there is no foundation, there is no superstructure over this particular building, right? Even there is no particular building, there will be some stress at this particular level. There will be some stress at this particular level. The calculation of this stress we have studied in effective stress chapter. The calculation of this stress we have studied in effective stress chapter, right? It means the stress value at this particular point, it will be due to this overburden pressure, right? Or due to the weight of this particular soil. That is your initial pressure, that is sigma naught bar. I am calling it as initial pressure, right? That is your initial pressure. Clear? Now after that you have constructed this particular superstructure. Due to the load of the superstructure, also there will be some stresses at this particular level. Again there will be some stresses at this particular level at the center of compressible layer, right? That is your delta sigma bar. So your effective stress changes from this value to this value. This is your change in effective stress, change in stress value. Clear? So this is due to your superstructure load, due to superstructure load, right? And this is due to your overburden pressure. Overburden pressure. Clear? Now how to calculate these stresses? Sigma naught bar, we know that we only have to take whatever is the gamma value of the material, multiply by this particular height, that will give me the sigma naught bar value. This stress value due to the superstructure, we know that whatever is the load at the base of foundation in soil, it is going to get distributed. In this particular soil, it is going to get distributed. Now generally examiner will give you that at what particular angle this particular stress value or load value is going to get distributed. If it is not given, you can remember the standard value it is 2 vertical to 1 horizontal. 2 vertical to 1 horizontal, right? So let's suppose your load value from the top is Q. Your load value from the top is Q. The width of foundation is B. The width of foundation is B, right? But you need to find out what will be the stress value at the center of compressible layer. You need to find out what will be the stress value at center of compressible layer. So to get that stress value, you have to divide this load with the area at the center of compressible layer. At the center of compressible layer, right? So let's suppose this width is B. It means I need to find out this particular dimension. I need to find out this particular dimension, right? So let's suppose this particular depth, it is Z. It is Z. It means I am moving Z down. If I am moving Z down, it means this will be what your, it will be your 0.5 times of Z. Yes or no? Or just for now, I'll write it as n times of Z, as this particular n value can be anything. I am assuming that it is n horizontal to 1 vertical. Clear? The load distribution is 1 vertical to n horizontal, or you can say n horizontal to 1 vertical, right? So it will be your n into Z. This particular value will also be n into Z. So you can find out what will be the dimension at the center of the compressible layer. If you will divide that particular load with this particular area, you are going to get this delta sigma bar. Clear? And if you will add these two values, you will get the final stress value, that is your sigma 1 bar, that is nothing but sigma naught bar plus delta sigma bar. So these are the parameters which will be needed for you to calculate the settlement value. Clear? Another formula for the calculation of settlement is your delta H. Third formula. These are the two formulas. Third formula is, or I'll write all the formulas again. It is delta H upon H is equal to delta E upon 1 plus E naught. This is your first formula. Second formula is delta H is equal to H into mv into delta sigma bar. And your third formula is delta S is equal to H into Cc upon 1 plus E naught into log base 10 sigma naught bar plus delta sigma bar upon sigma naught bar, right? Now this is new coefficient Cc. This Cc is your coefficient of compression. This is your coefficient of compression, right? This is nothing but your slope of E versus log sigma bar curve, right? So it is delta E upon log sigma 1 bar upon sigma naught bar. Clear? So this is the particular Cc value. So these are the three formulas by using which you can find out what will be the settlement at any particular clay layer, right? Now it's time for the questions. Next, there are some important formulas also. We are going to cover those with the help of questions only. Now try to focus on the question, read the question and give me the final answer. Read the question and give me the final answer. What this question says, what is the immediate settlement of concrete isolated footing 1.5 into 1.5 in size, founded at a depth of 1 meter in a silty soil whose modulus of elasticity is 90 kg per centimeter square. The footing is expected to transmit a unit pressure of 200 kilonewton per meter square. Take mu value is equal to 0.3. Do not apply any correction factor for settlement. G value is also given to you, right? You need to find out what will be the immediate settlement value. So 4 options are given to you. Just give me the answer. Just give me the answer. If you remember the formula for calculation of immediate settlement, just comment in the chat box. Otherwise, I will give you the formula. Yeah, Rahul. If you remember the formula for the calculation of this immediate settlement, just type in the comment box, otherwise I'll give you the formula for the calculation. Yes, Rakesh, Prashant. If you are in the live session, just comment so that it will be clear to me that okay, you are also there, right? So just show your presence by commenting on the session. Okay, I'll just let you know. We know that the immediate settlement, or sometimes we call it as a elastic settlement, it is your stress value Q into width of foundation into 1 minus mu square IT upon ES, right? Here mu we take for the soil, E also we take for the soil. Sometimes it may be possible that it will give you these particular values for foundation also, right? So always remember these are the values. Mu is your Poisson's ratio, E is your modulus of elasticity of your soil, right? Q, it is the pressure value at the base of the foundation, B is your width of foundation, IT is your impact factor, mainly depends upon the shape of your foundation, right? So this particular value you can take it as 1, as we do not have to apply any correction factor. Clear? Now put the values and give me the answer. You also will need to manage there also be need of to manage the units. So focus on the units also. We want the settlement value in centimeters. We want the settlement value in centimeters. Clear? So if I just put my Q value, it is given as 200 kilonewton per meter square. It is 200 kilonewton per meter square into B, width of foundation is 1.5 into 1 minus mu square. What is mu value given to you? That is 0.3. It's a square upon modulus of elasticity, that is 90. That is 90. It is 90 kg per centimeter square. 90 kg per centimeter square. I want answer in centimeter. So I can convert this B also in centimeters, right? If I convert this B into centimeters, it will be what? 10 to the power 2, right? This is your kilonewton per meter square. Can you also convert this particular value? Or simply if I convert this into the kilonewton, that also we can do, right? So it will be what? If I convert this centimeter square, this meter square into centimeter square, what will be it? It will be 10 to the power minus 4, right? Also 10 to the power minus 4, and I can multiply. Now it will become from kg. If I convert it into kilonewton, from kg, okay, we have converted it into meter only, right? We have converted this from centimeter square. This particular value we have converted. Also we can convert it 200. We can convert it as 200. This is 200 kilonewton per meter square. If I convert it into centimeter, it will be 10 to the power minus 4 centimeter square. Also I can convert it this 90 from kg to kilonewton. From kg to kilonewton. So it will be what? G value is your 10 meter per second square, right? So you can multiply with this particular value. Convert this and give me the final answer. Convert this and give me the final answer. Convert this and give me the final answer. Anyone? Okay, just see. The settlement value is Q into B into 1 minus mu square into IT upon ES. Right? Your Q value is 200 kilonewton per meter square. It is 200 kilonewton per meter square into 10 to the power 3. It will be now Newton per meter square into 10 to the power minus 4. Now it is Newton per centimeter square, right? And if I divide it with G, it will be in kg per centimeter square. If I divide it with G, now it will be in centimeter, sorry, it will be now in kg per centimeter square. So we have converted this into 1 minus 0.3 square upon 90. So this 90 is already in kg per centimeter square, right? Kg per centimeter square. Also we are having B. Your B value was given as 1.5, right? So this particular unit get cancelled out by this particular unit. This is in meter. If you convert it in centimeter, that is 10 to the power 2. It will give you the final answer. It will give you the final answer. It is 3.03 centimeter. It is your 3.03 centimeter, right? So any value you can convert, either this particular value into kilonewton per meter square, or you can convert this particular value into kg per centimeter square, right? So any of the value you have to convert. This value is given in kg per centimeter square. This value was given in kilonewton per meter square. Clear? So I hope the solution to this particular question is clear. So this type of unit conversion, it will be required for you to do, right? Okay, now this is the good question. Just read the question and try to find out. Just read the question and try to find out what examiner want to ask you. Just read the question and just let me know that what you need to find out. Just let me know what you need to find out. It is saying that the coordinate of 2 points on the virgin compression line are sigma 1 bar, it is equal to 400 kilopascal. Corresponding to this, your void ratio is 0.8. Second is sigma 2 bar, that is 800 kilopascal. Corresponding to this, void ratio is this particular value. In the field, a 3 meter thick normally consolidated layer of soil subjected to a construction load, and the average effective vertical stress increases from 200 kilopascal to 450 kilopascal. Determine the load increment to crave 25 mm final consolidation settlement. You need to find out the load increment for what? For 25 mm final settlement value. For final settlement value. Clear? Now how you can proceed to this particular question? Just let me know. You need to find out the load increment to crave the 25 mm final settlement value. You are having 3 formulas for the calculation of settlement, right? Now out of those formulas, what you need to find out? You need to find out that delta sigma bar value, right? It is mainly asking for your delta sigma bar value. Clear? It is asking for the delta sigma bar value. Just let me know. Just let me know how you can proceed. There are only 3 formulas for the calculation of settlement. Out of those 3 formula, which formula you can apply to this particular question, right? Just think about that and let me know if you got the answer or not. Process you got or not? Yeah, hello Rahul. I hope you are doing very great. Right? Okay. Now, how we can proceed? try to see what data is given to you, right? We know that the virgin compression curve, that is the curve of your E versus sigma bar, E versus sigma bar. Clear? Now, what are the data given to you? There are some points given to you on this particular compression line, right? Now, if I take this in the terms of log, I know that I am going to get a straight line in that particular case. Let's suppose this is the particular line, or this is your compression line. This is your compression line. This is your compression line. On this compression line, 2 points are given to you. On this compression line, 2 points are given to you. What are those points? Sigma 1 bar is 400, corresponding to that 0.8 void ratio. Your void ratio is 0.8, corresponding to 400, and corresponding to 800, 0.75. 400, this stress value is 400. Now, when stress value increases from 400 to 800, your void ratio decreases to 0.75. Your void ratio decreases to 0.75. Clear? Also, what it is saying, in the field, when there is a construction, your load increased from 250 kilopascal to 450 kilopascal. It means initially what was the stress in your soil? Before construction, the stress on the soil was 250 kilopascal. Can I say that this particular 250 kilopascal, it is my initial stress? It was my initial stress, right? So, initial stress is your sigma naught bar, that we denote with sigma naught bar. That particular value is what? That particular value is 250. That particular value is 250. Clear? Right. Now it is asking that if the settlement value is 25 mm, what will be the change in effective stress, right? What should be the change in effective stress, so that the final settlement value will be 25 mm. Clear? Now you know that if I apply this particular formula, delta H is equal to H into Cc 1 plus E naught log base 10 sigma naught bar plus delta sigma bar upon sigma naught bar. Out of this, what value is needed for me? This is E naught value, initial void ratio. So this E naught value will be required. This E naught value I need. Cc value I need. Sigma naught bar is known to me, 250. Delta sigma bar, it is asked. H value is given or not? H value. Yes, 3 meter thick, right? Your clay layer is 3 meter thick. It means H value is also given to you, that is 3 meter. H value is given to you, that is 3 meter. Right? So these are the two values which are needed you to calculate. This delta H is also given, that is 25 mm settlement. Your final settlement is 25 mm. Right? This is given that there should be 25 mm final settlement. Now based on this data, it means to calculate this change in effective stress, you will need this Cc value, you will need this E naught value. Can you tell me how you will proceed for these two values? What will be this Cc value? Can you calculate it from the graph? We know that Cc is your coefficient of consolidation, coefficient of compression, that is nothing but the slope of this particular curve. That is the slope of this particular curve, right? So if I say this as sigma 1 and this as sigma 2, right? This as E1, this as E2. I know that what will be the Cc value? It will be E1 minus E2 upon log sigma 2 upon sigma 1, right? That is 0.8 minus 0.75 divided by log 800 divided by 400, 800 by 400. Can you give me the value of Cc? Can you give me the value of Cc? Anyone? Just find the value of Cc. So here your multiple concept will be used, right? Give me the value of Cc. What will be the Cc value? That is your coefficient of compression. 0.166. 0.166. Clear? Second thing we need is E naught value. Don't take this 0.8 as E naught value. This is not your E naught value. It is given any particular point in the compression line, right? Now, can I say that the slope of this particular line is constant? The slope of this particular line is constant, and which is given by this Cc value. I can also write the slope of this particular line for these two values. Here the slope is Cc. Here also the slope is Cc. If I write for these 2 points, can I also write that Cc is equal to E naught, this particular value, minus E1 upon log this 400 divided by 250, 400 divided by 250. Just comment in the comment box, it is correct or not. Can I write Cc is equal to E naught minus E1 upon log 400 upon 250 for this particular portion? Slope is what? It is change in y with respect to change in x, right? So Cc value now is known to you. This particular value is known to you. E1 value is known to you, 0.8. You can find out what will be the E naught value. Give me the value of E naught. Give me the value of E naught. Give me the value of E naught. From this particular, give me the value of E naught. Yes, Prashant, very good. Yeah, thank you, Anjali. Give me the value of E naught. Just solve from here. This Cc value is now known to me, 0.166. 0.166, 0.833, right? So this E naught value is now 0.833. Clear? So now all the data are known to me. E naught is your 0.833. Cc value we have calculated as 0.166. Sigma naught bar value is known to me, that is 250. Clear? H value is given to me, that is 3 meter. This was the value? Yes, 3 meter. Right? So I can say that delta H is equal to H into Cc upon 1 plus E naught log base 10 sigma naught bar plus delta sigma bar upon sigma naught bar. Right? Just put the values. Delta H, it is, delta H is also given. Delta H is your 25 centimeter, right? Sorry, 25 mm. Clear? I'll just check. It is your 25 mm. Yes. Clear? So we can just say it is meter. So put the values. It will be H value is 3 into Cc value is 0.166 upon 1 plus E naught value. E naught value is your 0.833 into log base 10. Sigma naught bar value, that is your 250 plus delta sigma bar is needed to calculate upon 250. Just solve this. Just solve this. You can just solve for this. If you will take the inverse of this log, then only you can find out this delta sigma bar value. Right? Just solve this particular question, Prashant. You are getting it as 59.03. Okay, it is 59.03. So you are getting from here that delta sigma bar, it is 59.03 kilonewton per meter square. Kilonewton per meter square. Clear? So what will be your correct answer? The most appropriate answer is your 59 kilopascal. Most appropriate answer is your 59 kilopascal, right? It will be in kilopascal as all the values are in our kilopascal only, right? So it is your 59 kilopascal. Is this particular question clear to everyone? Just if you like this particular question, give me the signal in the chat box. If you feel that this is particularly a good question, just show that love in the chat box and try this particular next question. Try this next question. This is the another type of question which can be asked to you in the exam. Right? We have discussed about what are the different type of questions that can be asked from this particular chapter. This is the another part of that. Just try to read and give me the answer. This consolidation chapter, it is going to be very important for you. These type of question can be asked to you, right? So I'll just read the question for you. I'll simplify this question in an odometer test. This is the particular test used for the calculation of your settlement value or consolidation value, right? A clay specimen initially 25 mm thick attain 90% of consolidation in 10 minutes. Now this is the lab data given to you. This was the lab data. Now about field, it is saying that the same clay layer, the clay layer is same. The clay stratum from which the specimen was obtained has a thickness of 6 meter. This particular having a thickness of 6 meter and sandwiched between two sand layers. Clear? For a structure constructed on this clay layer, the ultimate settlement is estimated as 200 mm. Estimate the settlement at the end of 100 days. Estimate the settlement at 100 days. So, some lab data is given to you. Some lab data is given to you. You have conducted one test in lab and you have find out that the 25 mm thick sample layer, it will undergo 90% consolidation in 10 minutes. It will undergo 90% consolidation in 10 minutes, right? Now, by using this particular lab data, now you need to find out that what will be the estimated settlement in 100 days in your field. What will be the estimated settlement in 100 days in your field? That you need to find out. Clear? And these settlement values are in mm. Note the units. These settlement value you need to find out in mm. How you can proceed? Just let me know. I'll just give you some time so that you'll be able to find out. So that you'll be able to find out. What you can find out from this lab data? What will be needed for this particular time? Can we say this is the particular question from that particular chart? Whatever is that curve we have seen, that particular cycle we have seen, right? Time is given to you. Time is given to you and it is asking for the settlement value. Time is given to you and it is asking for the settlement value. Now in that particular cycle, time is given, settlement is asked. Try to see that what values are not given and those values which are not given, can you find out those values from this lab test? Right? So, again I will draw that cycle for you. Clear? So, now time is given to you, that is 100 days. Time is given to you, that is 100 days, and it is asking that for this time what will be the settlement value. For this time what will be the settlement value. Now you know that from time to settlement what will be the process. It will be, first you will need that TV value, that is nothing but CV into T by D square. After this you will need, once TV value is known to you, you can find out the degree of consolidation. If it is more than 60%, sorry, if it is less than 60%, it will be pi by 4 TV is equal to pi by 4 U square, or if it is more than 60%, it will be 1.78 minus 0.9332 log base 10, 100 minus U percentage. From here, once U value is known to you, then you can proceed to U is equal to delta H upon delta capital H, and from here you can find out this, right? And from here you can find out this. Now try to see what data are given, right? Based on this particular chart, now we'll try that what data are given to me. For 100 days I want that TV value. It means I want this CV value, this T value is known, this T value is known, this CV value I have to find out, right? I have to find out. This D value, this is your length of drainage path. Now try to see, for the field data, it is having a thickness of 6 meter and it is sandwiched between the two sand layer. So there is a 6 meter thick sand layer, sorry, there is a 6 meter thick clay layer. This is your clay, and it is sandwiched between sand. Here also it is sand, here also it is sand. Can you tell me what will be the D value? What will be the length of drainage path? Just in the comment box. If you know the concept how to find out the length of drainage path, just let me know what will be the drainage path in this particular case. I have told you that the length of drainage path, it is the maximum length which one water particle have to move before expelling out from this particular clay layer. Give me the answer. It will be 3 meter, right? So I know that the water molecule either it can remove from the sand layer either at the bottom or either at the top. So the particle which is at center, it has to travel the maximum distance, right? What will be this? 3 meter. This particular condition we call it as a double drainage condition, right? So in double drainage condition, if this thickness is your H value, so what will be length? This D will be your H by 2. Clear? So what will be this H by 2? It is 3. It means now this D value is known to me, that is 3, right? Or 3 meter I will say. It means this CV value is first needed. I need to find out this CV value. Now for finding out this CV value, some lab test you have conducted. Some lab test you have conducted, right? So there is a sample of 25 mm. There is a sample of 25 mm, right? Now if you have taken this particular sample from this clay layer, so you have to assume here also the double drainage condition, right? It means for this particular value, what will be my D value? It will be 25 by 2. Yes or no? It will be 25 by 2 for this particular clay sample, right? You cannot take the 6 meter of clay layer to the lab, right? So from that lab, you have just taken one particular sample of this particular 25 mm and you have conducted the odometer test on that 25 mm thick sample layer. So for the lab, what will be the thickness of my clay layer? It will be 25 mm. So what will be the drainage path in lab? It will be 25 by 2, right? It means D value is known to me. Degree of consolidation is known to me 90% and time is known to me, right? So first I will write for the lab. If I write for lab, what is the data? In lab, I know what is the thickness of sample, that is 25 mm. So from here I can say that my drainage path, it will be 25 by 2 mm, right? Degree of consolidation is given to you, that is 90%, and it take a time of 10 minutes. It take a time of 10 minutes. Now this particular data, it is mainly given you for the calculation of CV. Now I know that for calculation of CV, this particular formula we can use. TV is equal to CV into T by D square. But to use this particular formula, I will need this TV value. I know for more than 60% of degree of consolidation, this TV value will be 1.78 minus 0.9332 log base 10, 100 minus U, 100 minus 90. Give me the value of TV. Give me the value of TV. From here, give me the value of TV. Yes, Prashant, give me the value of TV. How much time factor you are getting? Clear? First, let me know in the chat box if now the question is clear, what it is asked and how we have to proceed. We need to find out what will be the settlement value for any particular time in field. But to find out the properties of soil, which property of soil? This particular CV value. This field you have conducted this lab test, and based on that lab test you can find out the CV value, right? Give me the value of TV. Give me the value of TV, 0.848, right? We know for 90% consolidation we also remember this value, 0.848, right? Now if I put here that TV is equal to CV into T by D square, 0.848, it is equal to CV into T. Your T is your 10 minutes. D value is your 25 by 2. 25 by 2 square. Give me the value of CV. Give me the value of CV. Give me the value of CV in mm square. It will be in mm square per minute. In mm square per minute. Give me the value in this particular unit only. What is the CV value you are getting from here? What is the CV value you are getting from here? Yes, Prashant? Yes, Prashant? I am getting it as 13.23. Just also check your answer. I am getting it as 13.23. Just let me know in the chat box if you are getting the same answer for the CV. Now, this particular soil you are not changing. Whatever is the soil in lab, same soil it is in the field, right? For this particular soil only you have conducted the test. It means the CV value in the clay layer which is in lab, this particular CV will be same for your, this will be in mm square per minute, right? These were on the mm only. Your 25 was in mm. So it will be mm square per minute only, right? We can change it later, right? Yeah, it will be 13.25 in that case. Yes or no, Prashant? Right? So this is your CV value. Now I can use this CV value 13.23 here. Now I have find out this particular value as 13.23. As 13.23. Now can you give me the value of TV for this particular case? Can you give me the value of TV for this particular case? Now 13.23, it is known to me. Time is our 100 days. Time is our 100 days. And this is your in mm per minute, mm square per minute. It is in your mm square per minute. It is your mm square per minute. Right? So days you can convert into minutes, and this 3 meter you can convert into mm. You can convert it into mm. 13.25 mm square. See, Prashant. From here, you are not getting it as 13.23 or 13.25 mm square per minute. You are getting it as, okay, mm square per minute, right? Now, your d value is now 3 meter. Convert it to mm. 3000 square. This is your d square. Time is your 100 days. Convert this 100 days into minute. That will be 100 days into 24 hour into 60 minutes. Now all the units are in mm square per minute. So from here you will get a TV value. Give me the value of TV. Now your CV value is known to you. Now the time for which we need to find out the settlement value, that is 100 days. Now we are coming to the field conditions. These are the calculation now for field. Now we are moving to the field. Once CV value is known to me from the lab data, now I move to the field. What is the TV value you are getting? What is the TV value? So I'll write it clearly here, right? So TV is equal to CV into T by D square. TV value we need to find out. CV is my 13.23 into time is your 100 days. I'll convert it to minute, right? By D value. D is your 3 meter, that is 3000 mm. What is the TV value from here? 0.216. 0.216. 0.216. Right. Now I am assuming that this TV value is corresponding to the degree of consolidation less than 60%. I am just assuming, it is not known to me, right? So I can use that TV is equal to pi by 4 into u square. From here, can you give me the value of what is the degree of consolidation? Use the TV value, find out the value of degree of consolidation, right? We have just moved to the next step. Once TV value is known to me, now I want to find out this u value. First, I am assuming that, okay, my degree of consolidation is less than 60%. If this analysis or if this assumption will be true, I'll use this particular formula. If that assumption will be wrong, if my u value it will come greater than 60%, then that case I will use this particular formula, right? But first I am assuming that it is less than 60%. Just check what is the value of u corresponding to this TV value. It will be under root of 4 into TV by pi. It will be in decimal, right? If you want to find out in percentage, multiply it with 100. How much value you are getting for this u? This u will be in decimals. If you want in the percentage, you have to multiply it with 100. 52.45. It is 52.45. It means it is less than 60%. So our assumption is true. So it means this particular value is correct. 52.45. Right. Now this particular u value is known to me. This u value is known to me, that is 52.45, or I can write in terms of decimal 0.5245. Clear? I need this delta H value. What is the total settlement? What is the total settlement? Ultimate settlement is estimated as 200 mm. Estimated ultimate settlement is given to you 200 mm. Right? So this value is your 200 mm. Now give me the delta H value. Give me the delta H value. Yeah, hi. Good evening, Himanshu. From here, give me the small delta H value. What will be the settlement in 100 days? What will be the settlement in 100 days? It will be 200 multiplied by 0.5245. It will be just 105 or around that. Just check, or 103. Clear? 200 multiplied by 0.5245. What is the value? 104.9 or 105 around, right? So we can just check with the options. So 104, that is the most appropriate answer. 104, that is the most appropriate answer. So the correct answer for this particular question will be your option number B. Clear? Yeah, I hope the solution to this particular question is clear. Is it clear to everyone? Just let me know in the chat box so that we can proceed. Is this particular concept clear or not? So this type of question, either from the settlement formula or either from this particular cycle, you will get the question. You will get the question, right? So you need to find out that what are the different data given to you and how to proceed to the particular answer. Clear? Now, most important part for your soil mechanics or from your gate point of view is strength of soil, that is shear strength of soil. Second is your lateral earth pressure and stability of slopes, right? So in shear strength of soil, we'll find out that what is the particular stress value at which your soil will get failed, right? What is the strength of any particular material? If we talk about the strength of any particular material, right? If we talk about the strength of any particular material, we know that we can define it in the two ways. First way is what? First way is it is that maximum stress value. It is that maximum stress value at which your soil is safe. Clear? Or you can say it as this is the minimum stress value at which your soil will get failed. What is the meaning of this? Let's suppose I am saying that any particular material having a strength of 50 kilopascal. Clear? It means how much load you can safely apply on that particular material before failure. On that particular material before failure, you can apply only the maximum load as 450 kilopascal. You can also apply 250 kilopascal. At that particular stress value also, that material will be safe. At 100 kilopascal, that material will be safe, right? But if I am saying that the stress value, let's suppose 500 kilopascal. Clear? Any material having this particular strength. So I can load this material safely with 100 kilopascal also, with 200 also, with 300 also, with 400 also. But the maximum load which this particular material can take without failure, that will be 500 kilopascal. So from safety point of view, I can say that this is the maximum stress value at which my material is safe. But if we talk about the failure, what we can say? If I apply a stress of 1000 kilopascal on this particular material, if I apply a stress of 1000 kilopascal on this material, it will get fail. It will get fail even at 800 kilopascal, even at 700 kilopascal, right? So at which stress value, what will be the minimum stress value at which it will get fail? That will be the 500 kilopascal value, right? So from the failure point of view, this is the minimum stress value, right? So when it was safe, you have to take the maximum stress value at which it is safe. From failure point of view, you are saying it is the minimum stress value. Clear? Right? So we are having different type of strength: compressive strength, tensile strength, shear strength. Why we are concerned about the shear strength of soil? As we know that the soil fails in the shear, right? When you will apply the vertical load over this, your particles, they are going to slide over each other. Clear? And this type of failure, you will call it as a shear failure. That's why we are more concerned about the shear strength of soil, right? Now this particular shear strength of soil, in particular soil, it will be due to the two reasons. It will be due to cohesion, right? That is the interparticle attractive forces between the particles, and it will be due to friction. It will due to the friction also. There is one more factor, that is your interlocking between the particles. But by now we are not having any particular methodology to measure the strength due to interlocking. So we consider only the strength due to friction and strength due to this cohesion. Cohesion is what? It is the force of attraction between the like particles, right? So here our particles are soil. So whatever is the interaction forces between the soil particle, that will be our cohesion. So according to Moore-Coulomb, the shear strength of soil, it is given as C plus sigma and tan phi, right? It is given as C plus sigma and tan phi. From this particular graph also you can see there are two factors. One is the cohesion. This cohesion, remember that this particular cohesion, it is independent of the loading, right? The main factor, the main difference between the soil and any other particle is what? Here the strength also depend upon the loading. If we talk about steel, if we talk about the concrete, you write that the characteristic strength of a M25 concrete is 25 megapascal, right? So it means whatever is the loading on that concrete, its strength is going to remain same, it will not change. But here you can see that the strength of soil, it is the factor of cohesion which is independent of independent of loading, but this particular parameter, that is friction, it is dependent upon the loading. This stress value, that is the normal stress value, it depends upon the loading. So in soil, your strength of soil, it depends upon loading condition also. Clear? That's why this particular analysis is complicated, right? So if I represent it into tau versus sigma, so this is particularly your soil failure plane. It means these are the different shear stress value corresponding to any normal stress at which your soil will get failed. So you can see that corresponding to this stress value, when stress value is 0, this was the strength of your soil. At this particular point, this is the strength of your soil. At this point, the strength of soil is this. So with increase in stress value, your strength of soil, it is going to get increase. Clear? Now when this particular Moore-Coulomb theory was given, at that particular time Terzaghi has not given the concept of your effective stress, right? But we have discussed in the last class also that it is not the pressure of water which is responsible for the particle to move into a closer contact. That particular stress value which will be responsible is your effective stress. So this particular parameter, they should be the function of effective stress, right? So this particular we call it as a modified Moore-Coulomb theory. Clear? So this is the particular modified Moore-Coulomb theory where you are taking into account the effective cohesion, the effective friction, and your effective stress, right? Or effective normal stress, you can say. Yeah, thank you, Kanu. Right. So this is particularly your cohesive component, and this particular value, it is your frictional component. So this value is constant, this cohesion value is constant, but with loading, this friction component, it is increasing, right? So your soil strength, it is the function of cohesion and this particular friction component. This friction component, it depends upon the loading. This is one important part from this particular chapter. Next important part is this Moore circle analysis. Now this particular Moore circle analysis is very important, right? In this particular chapter, what we need to find out? We need to find out the strength of soil. Strength of soil is nothing but the maximum stress value, maximum shear stress value at the time of failure, right? So let's suppose I have taken an element of soil. If these are the stresses acting on this, now these are your normal stresses, right? Sorry, these are your principal stresses. So this is your principal stress sigma 1, that is major principal stress if I say, and this is your sigma 3. So what will be the shear stress and normal stress? What will be the shear stress and normal stress along any particular plane? Either you can find out it analytically, you might have seen the different formulas. You might have seen the different formulas in your SUM, right? Also, you can do this particular analysis by Moore circle. So what this Moore circle represent at different planes which is passing through a particular point, what will be the shear stress value corresponding to any particular normal stress value, that is particularly given by this Mohr circle, right? So any particular point in this Mohr circle, any particular point on this Mohr circle, it is giving that what will be the normal stress and what will be the shear stress value along this particular plane, along this particular plane. As we know that from one point there can be infinite number of planes which are passing. From one particular point there can be infinite number of planes which are passing, right? So you will get, if you add all those points, you will get one circle, that is nothing but your Mohr circle, right? Now here we are more concerned about the failure point. Let's suppose you have applied this loading and due to this loading your soil get fail along this particular plane. Your soil get fail along this particular plane. I am just saying it as a theta at failure. This is the theta at failure. Clear? So this theta at failure, it is given as theta at failure is, it is your 45 plus 5 by 2. 45 plus 5 by 2. What is this phi? This phi is your angle of internal friction. What is this phi? This phi is your angle of internal friction. What this phi represents? Let's suppose this is the shear stress value. This is the normal stress value, right? So this, there will be one resultant, right? So when this shear stress value keep on increasing, when this shear stress value on this particular plane keep on increasing, this resultant, it will shift from this normal towards this tau value, right? If let's suppose initially tau value is 0, so this resultant will be in the direction of sigma normal. Now you are keep on increasing the shear stress, so your resultant, right? Okay, so your resultant it is going to get shifted in this direction. At any particular value of this angle, at any particular value of this angle which is made with the normal, your material is going to get fail, right? So this particular angle we call it as a phi value. So this is the maximum angle which is made by the resultant with this normal, and this you call it as a angle of friction. Here we call it as a angle of internal friction of soil. Here we call it as a angle of internal friction of soil. Angle of internal friction. Clear? Right? This one, it is the very important relation which will be used in this particular chapter and all other chapters, right? So I call this particular question personally as GOAT equation, right? It is the greatest of all time equation, you can say, for your GATE exam, right? So what is this particular equation? It is sigma 1 bar, it will be is equal to sigma 3 bar tan square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2. So wherever you will find out the effective stresses, wherever you will find out the principal stresses, this is your major principal stress sigma 1, sigma 3 is your minor principal stress. So in whatever question you find out the principal stress, right, and you need to find out the relation between this tau and c, that is phi value and c value. These are your parameters for the calculation of strength, right? So if sigma 1 and sigma 3 is known to me, I can find out what will be the c and phi value. Clear? So these are the two unknowns. If sigma 1 and sigma 3 are known to me, I can take the two datas. So I will get two equations in terms of sigma 1 and sigma 3. From there I can find out what will be the c and phi value. Clear? Once c and phi value is known to me, I can find out what will be the shear strength of soil at any particular stress value, at any particular normal stress value. Clear? Right? Now the most important part from this particular chapter, one is this particular equation, you can remember. Second most important part from this particular chapter, that will be your triaxial test. That will be your triaxial test. Now try to understand what this triaxial test suggests, right? If I talk about any particular element below soil, let's suppose this is the ground level. If I am considering this particular material, so this particular material, it will be subjected to any particular stress value, as all around there is a soil, so it is subjected to one confining pressure. If you are constructing one building here, there will be some extra pressure over this, right? There will be some extra pressure over this. So this particular condition, it was performed in the lab also in this particular triaxial test. So this particular test, it is conducted into two phases. First stage is your confining pressure stage, in which you are applying the all around water pressure on this. Just like here, this particular soil material, it was subjected to a confining pressure from all the direction, right? So to implement this particular value in the lab, what we have done, we have subjected our stress element, our element with the water pressure. Clear? This first stage we call it as a confining pressure stage. So we have applied this sigma c value. Clear? In second stage, now the stress due to this particular building is mainly responsible for failure. If you will keep on increasing this building load, there will be one particular stress value at which this material will get fail, that particular stress value we need to find out, right? So once the first stage is completed, we move to the step number 2 or stage number 2. Now we have applied a deviatoric stress. Now this deviatoric stress, it is applied gradually. It is not like you are applying it suddenly, you will apply it gradually, right? So you are keep on increasing. Let's suppose first you have applied 1 kilonewton, then 2 kilonewton, then 3 kilonewton, you will be applying the load, right? You cannot apply stress value. You might be applying the weights. So 1 kilonewton, then 2 kilonewton, then 3 kilonewton, right? At one particular stress value, this particular material, it will get fail. Clear? At that particular point, whatever is the stress value, that will be my deviatoric stress. Now remember, this deviatoric stress will not be known to me. What will be known to me? The value which will be known to me will be the load at which this particular material get failed. So this P value will be known to me. If I divide this particular P value with the area of this sample, then I can get this deviatoric stress value, right? So all these are your questions for your exam, right? So then I will get this deviatoric stress value. Now the problem is, when I have prepared the soil sample, generally we use a cylindrical sample in this particular test, right? Which is having length to diameter ratio as 2. Clear? So there will be a cylindrical sample like this, whose length to diameter ratio, it will be 2, right? So your L by D ratio, it will be 2. Clear? Now the problem is, initially I know what is the cross sectional area of this particular sample. Initially it is known to me that what is the cross sectional area of this sample, but at the time of failure, what will be its area that I should use for the calculation of stress value, as on that particular area this particular load is acting at the time of failure. So it means it will be this stress value, it will be load divided by area at failure, right? It means this is the particular parameter which is not known to me. Remember, this area of failure, it is not known to me. I have to determine it by one particular formula that I will discuss later. But remember that the deviatoric stress value, it will be the load at which your soil get failed divided by area at failure. Clear? Now come to this particular test. These are the two stages. You have applied this triaxial sigma 3 value. In second case, you have applied this deviatoric stress value. Clear? Can I say that? Okay. Can I say that this particular condition is like this? In first condition, you have applied this sigma c value. you have applied its sigma c value. This was your first stage. At this particular point, your first stage get completed. After that, you started giving a deviatoric stress value. You keep on increasing this value. You keep on increasing this value, right? And at the time of failure, when just this sample will get failed, you will note down what is this sigma d value. What will be this sigma d value? Clear? This particular condition, I can represent also it as this, that this particular value sigma d plus sigma c, can I say it is my major principal stress, that is sigma 1, that is sigma 1, and this is my sigma 3, this is my sigma 3, right? So what is the confining pressure you have applied, that is known to you. At what stress value your material get failed, it is known to you. It means sigma 1 and sigma 3 is known to me. Once sigma 1 and sigma 3 is known to me, I can easily draw the Mohr circle. I can easily draw the Mohr circle, right? As for drawing any particular Mohr circle, for drawing the Mohr circle, what will be the data needed to you? What will be the data needed to you? The data needed will be the center coordinates and the radius of circle. We know that the center of circle or center of Mohr circle, it is at the coordinate of sigma 1 plus sigma 3 by 2 comma 0, right? And what will be its radius? Its radius will be sigma 1 minus sigma 3 by 2. Sigma 1 minus sigma 3 by 2. Clear? It means radius is known to me, center is known to me. I can draw this Mohr circle. For any other data, now I will change this sigma c value. Again I will repeat the test. Again I will get one more Mohr circle for different sigma c value. Again I will change this sigma c value. I will get new sigma 3. I will get new sigma 1. Corresponding to that, I can again draw one Mohr circle. And if I will join these Mohr circle, the common tangent to these Mohr circle, it will give me what? It will give me the failure envelope, right? So I will get this C value, I will get this phi value. Once C and phi is known to me, I know that shear strength of soil, it is C plus sigma and tan phi. It means from here I can find out what will be my strength. I can find out what will be my strength. Is that clear? This is the graphical method. I can also use, once sigma 1 is known to me, sigma 3 is known to me, second value of sigma 1 and sigma 3 is known to me, I can use that particular GATE equation, right? I can use this GATE equation. Sigma 1 value, sigma 3 value is known to me, right? If 2 sigma 1 and 2 sigma 3, sigma 1 in test number A corresponding to this is sigma 3A. I have conducted the test again. I will get for sample number B, sigma 1B and sigma 3B. So these are the two equations. These are the two unknown C and phi. So in the numerical, you have to find out this C and phi value by using these equations, right? As you will not get any particular graph paper in the exam, so generally we use these analytical equations for calculating this C and phi value, right? Now, there can be 3 number of tests based upon what is the drainage condition. If in the starting stage you are not allowing the drainage, you will call it as a unconsolidated. Clear? But if you are allowing the drainage, if you are allowing the water to escape from the soil, it will be consolidated. Similarly, during second stage, either you call it as a deviatoric stage or sometimes you call it as a shearing stage also, as at this particular stage your soil is going to get shear. Here also, if you are not allowing the drainage, it will be undrained condition. If you are allowing the drainage, it will be a drained condition. Clear? So based on the drainage, your C and phi value, they are also going to get affected. Also, you are having these number of tests. So you are having CD test, right? I will start with UU test. Your UU was unconsolidated undrained test. It means during first stage, during shearing stage also, you have not allowed the soil to get drained. second U, that is unconsolidated, undrained. In second stage also you have not allowed the soil to get drained. Second is CU test. Second is CU test, that is consolidated undrained test, right? Third is your CD test, that is consolidated drain test. So these are the three tests which you generally conduct in your particular soil during this Triaxial test, right? So these are having their application in the different type of soil. If we talk about the UU, in which type of soil you can use? In the clay, right? In clay, for the sudden loading or for a small time interval, we know that clay is having very less permeability, so there will be no expulsion of pore water in that particular soil. So this UU test will give the better result as compared to other tests, right? We also have CD test. Like in sand, we know that when we will apply the load, it is having a high permeability, so there will be expulsion of pore water from the soil. It means there will be drainage in the soil, right? So you can just use this CD test, clear? But the time for this CD test, it almost take around 1 or 2 weeks. So generally either you can go for CU test or UU test, right? Now we were talking about that to find out what is the deviatoric stress value. We know at what particular load my soil get fail, divided by area at failure. Now this area at failure is known to me, this area of failure is not known to me, but the initial area is known to me when I have prepared the sample. When I have prepared the sample, what was the area, that particular value is known to me. So from there you can find out what will be the particular area at the time of failure. So this is your area at failure. It is A0 upon 1 plus epsilon z, means what is the decrement or what is the strain value along length, clear? This is mainly applicable for UU test, as in UU test there will be no volume change. In any particular other test, if there is a volume change, so it will be your area at failure will be A0 into 1 plus minus volumetric strain upon 1 minus strain in length, or either you can say strain in z direction, clear? Now this sigma d value which you are getting at failure, you call it as a confined compressive strength. Confined compressive strength. Confined compressive strength. Remember, this is not the strength of soil. What student do the mistake? Sometimes it is asked that to find out the confined compressive strength. It means it is asking for sigma d value, right? You know that the sigma d value is different, your tau f value is different. Your tau f value is different, right? So if it is asked to calculate the confined compressive strength, it means it is asking for the sigma d value. I hope it is clear. There is one particular special case of this test in which your confining pressure is 0. If sigma c is 0, we can say that there will be only sigma d, that is also in vertical direction. So can I say that sigma 1 will be is equal to sigma d and sigma 3 will be is equal to 0. Sigma 3 will be is equal to 0. In this particular case, my sigma d value, this is known as your unconfined compressive strength. As there is no confining pressure, so we call it as an unconfined compressive strength test, and this particular value you call it as a unconfined compressive strength. Unconfined compressive strength, right? And this particular value you also use the abbreviation as UCS value. You use the abbreviation as UCS value. I hope it is clear, right? Now one special case I want to discuss, that if I use the 5-star equation or that particular GOAT equation, that is your sigma 1 is equal to sigma 3 tan square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2, right? Now I am using it for this particular unconfined compressive strength test. it means my sigma 3 value will be 0. My sigma 3 value will be 0. If I assume that my soil is purely cohesive, it means phi value is 0, right? So for this particular special case, what will be the value? I can say sigma 1, it is equal to sigma deviator, it is equal to nothing but UCS value. This sigma 1 is equal to sigma deviator, it is equal to UCS value. We sometimes represent it with QU, right? So what will be the value of QU? Your QU, it is going to be equal to, this value will be 0 at sigma 3 is 0, right? This particular value 1045 plus 5 by 2, it will be now 1 as phi value is 0. So what will be QU value? It will be QU is equal to 2 times of cohesion, 2 times of cohesion, right? So here unconfined compressive strength in case of purely cohesive soil, it will be is equal to 2 times of cohesion value. Clear? Now, next part is your Vane shear test, right? Next topic is your Vane shear test. So in this particular test, you'll just insert the vane in the soil, you rotate, you will get a particular torque value at which your soil will get shear, and based on what is the diameter of this particular diameter of this particular shaft and what is the height of that shaft, we have derived one relation for calculation of shear strength of soil. For the calculation of shear strength of soil. Now remember that this particular shear strength of soil formula which you remember, it is having one assumption that the stress distribution, it is uniform over the top, over the bottom and over the sides. You are assuming that the stress distribution, it is uniform. Then in that case only you are getting this particular formula. You might have remembered it like that, tau f is equal to T upon pi d square h by 2 plus d by 6, right? So this is the particular formula when your stress distribution, it is uniform. Clear? Or shear strength, it is uniform. But examiner can also change this particular distribution or stress distribution pattern. Clear? That will be a very good question. If examiner will change this stress distribution pattern, let's suppose examiner has taken that your stress distribution, it is like this, triangular. So in that case your formula will get changed. You can also derive this particular relation. I will also give you the direct relation in this particular session. So in that particular case, this will be your shear strength of soil. Clear? So your shear strength of soil, it will be what? It will be T upon pi d square h by 2 plus, in case of d by 6, it will be d by 8. It will be your d by 8, right? So T upon pi d square h by 2 plus d by 8. When this particular formula, it will be applicable when your stress distribution at top and bottom, it is what? It is triangular, right? It is 0 at this particular shaft point and it is maximum at the end of this particular bleed. Clear? Right? So this is also one important formula for you. Now we'll move to the questions. Now it's time for the questions, right? Now see the question and try to find out what is asked in the question and how you will proceed. Whatever is the points required for this particular calculation, that I have already given to you. Just give me the answer fast so that we will be able to cover foundation part also. Just give me the answer. Just give me the answer. Yeah, thank you, Sandeep sir. What it is asking in the question and what you need to find out, just calculate. If you have not liked the session by now, just like the session. Also share the session if you find out that this particular session, it can be important for other students also. So you can also share this particular session with your friends, right? And if you have not liked the session by now, just like the session also. Just comment in the chat box so that it will be known to me that who are the students who are still with me in this particular session. Just comment in the chat box so that it will be known to me that who are the students who are still here with me. Prashant, are you there? Okay, just read the question. I'll just explain it for you. A saturated sample of C5 soil failed at a deviator stress of 470 kilonewton per meter square. I'll mark with here. It is your sigma d value given in a drained triaxial test. Right. The angle between the failure plane and horizontal is 65 degree. Take the cohesion value as 20 kilonewton per meter square. The value of principal stresses. First, give me the answer in chat box. By seeing this particular question, is it known to you which equation you are going to use? Just give me the name of that particular equation. Which equation we are going to use in this particular question? Just by seeing the data. Which particular question? We have just discussed that particular name. What was the name given to this particular equation which we are going to use in this particular question? Right. So you need to find out the principal stresses. It means yes, GATE equation we are going to use. Right. So we need to find out sigma 1 and sigma 3 value. We need to find out sigma 1 and sigma 3 value, principal stresses it is asking. Clear? And sigma d value is known to me. So it is clear to me that okay, the equation which will be used is GATE equation. The equation which will be used is GATE equation. So we know that GATE equation is nothing but sigma 1 is equal to sigma 3 tan square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2. Now out of this particular data, what is known to me? Sigma 1 is not known to me. Sigma 3 is not known to me. Phi value is not known to me. What known to me is C value. What is the cohesion value? Cohesion value is given to me is 20 kilonewton per meter square. 20 kilonewton per meter square. Also one angle value is given 65 degree. Can you tell me this 65 degree, it is the value of theta or phi? In this particular shear strength of soil, we are only having two angle values. One is angle of failure, second is your angle of internal friction. By seeing the data, just let me know if it is the value of theta or if it is the value of phi. This is the value of theta or this is the value of phi. Just give me the answer. By seeing the data, just give me the answer if it is the value of theta or it is the value of phi. We know that theta is the angle of failure from the principal plane, right? So it is given that the angle between failure plane and horizontal, as we are mainly assuming that this is my major principal plane, right? We are taking it as sigma 1, this is as sigma 3. So this is my major principal plane, this horizontal line, and this is, if this is the failure plane, so this particular angle we have called it as theta or theta at failure. Theta at failure. It means this is the value of theta. Yes, this is the value of theta, right? So theta value is given to me, that is 65 degree. Theta value is given to me, that is 65 degree. What was the C value? C value is also given to me as 20 kilonewton per meter square. It has 20 kilonewton per meter square. Now if we see how many unknowns are there in particular equation, there are three unknowns. There are three unknowns. With one equation, how many unknowns we can find out? With one equation, how many unknowns we can find out? Can you tell me how many unknowns we can find out using this one equation? Only one unknown? Yes or no? We can only calculate the one unknown using this particular one equation. It means I have to eliminate these. I have to eliminate these unknowns so that there will be only one unknown. How I can eliminate? Also sigma d value is known to me. What is sigma d? Deviatoric stress value 470. that is 470 kilonewton per meter square, right? So I can write this sigma 1 as sigma 3 plus sigma d. So now this unknown is gone, right? Phi value, can I write this 45 plus pi by 2 as theta at failure? As we know that theta at failure is equal to nothing but 45 plus phi by 2. Theta at failure is nothing but 45 plus phi by 2. So, right. So this particular value I can write it as 45 plus phi by 2. So this phi is removed now, sigma 1 is removed now. The only unknown left is sigma 3. The only unknown left is sigma 3, right? So I can write this particular equation as, sigma 3 plus sigma deviator, it is equal to sigma 3 10 square. 45 plus 5 by 2 I can write 10 square theta at failure plus 2c 10. 45 plus 5 by 2 is nothing but your theta at failure, right? Sigma 3 is known to, sigma 3 I need to calculate. Deviatory stress is given to me 470, right? Sigma 3 again need to calculate it. 1065 degree, its square plus 2 into c value is known to me, that is 20 into 10, 65 degree. I hope you will be able to calculate what will be sigma 3 value from here. Now there is only one unknown, this sigma 3. Give me the value of sigma 3. Give me the value of sigma 3 from this particular equation. Give me the value of sigma 3 from this particular equation. Yes, Prashant. Solve this particular equation and give me the value of sigma 3. I'll just also check what is the particular answer I am getting. I am getting it as 106.76. Just let me know in the chat box if you are getting the same. 106.76 kilonewton per meter square. Are you getting the same answer? Once sigma 3 is known to me, I can find out sigma 1 is nothing but sigma 3 plus sigma d. Sigma 3 is 106.76. Sigma d is 470. So it will be what? It will be your 576.76. It will be your 576.76. Right? Yes, 106.76. If we add 470, it will be 576.76. Clear? So what will be my answer? Sigma 1 is 576 and sigma 3 is 106. So 576.73 and 106.73. My option number B will be correct. My option number B will be correct. Is it clear to everyone? Is it clear to everyone? Right? Should we proceed? Okay. Okay. Can you calculate this particular value? Can you calculate? This will be particular question. It will be homework for you, right? I'll just give it a homework to you. Just what it is asked in the question: in an unconfined compressive strength test, the clay sample having a length of 8 cm and 4 cm diameter fails under a load of 120 Newton. It means this is the P, load at failure value is given to you at 10% axial strain. It means this is the epsilon Z, it is given to you 10%. Right? What will be the value of shearing resistance taking into account the effect of change in cross section of the sample? Change in cross section of the sample. Right? So the best trick in this particular question, it is what? Once you will solve, what you will get after solving this particular question, you will get QU value first. QU will be your unconfined compressive strength. That will be P at failure upon area at failure, right? Area at failure you can calculate. This is the diameter. This is the diameter. It means pi by 4 d square. It will be your A naught value. Pi by 4 into d square. It will be your A naught value, right? So once A naught value is known to you, you know that area at failure is equal to A naught upon 1 minus strain in Z length. So area at failure will be known to you. P at failure is known. QU is known to you. But it is not asking for unconfined compressive strength. It is asking for the shear resistance. Remember, it is asking for shear resistance. It means shear strength of soil. If it is a clay sample, if it is a clay soil, I know that shear strength of soil will be is equal to what? Cohesion. As we know, tau f is equal to C plus sigma and tan phi. If phi value is 0, my strength of failure or strength of soil in clay soil, it will be is equal to cohesion, right? QU value is known to me. Strength of soil is equal to cohesion. We have derived one relation that is this QU is equal to 2 times of C. QU is equal to 2 times of C. It means what will be this strength in soil? It will be QU by 2. It will be QU by 2, right? So what most of the students do mistake in this particular question, they used to calculate this QU value, that is axial, that is your unconfined compressive strength value, UCS value, and they used to mark the answer, right? If you will find out this QU value, that option will be also available in the options, but it is not asking for QU value, it is asking for the tau f value. It will be what? It will be QU by 2. By that same concept which we have discussed. Clear? So you can just find out the answer of this particular question and you can let me know in the chat box. This will be a homework for you, right? Now, this particular question if you can answer. Last question, if it is clear to you, just let me know in the chat box. Whatever we have discussed that particular question and for the homework, is that clear to everyone? Is that question clear? If that question is clear, just now try to answer this particular question. Read the question and try to answer. Read the question and try to answer. What this question says, a shear vane 7.5 centimeter diameter and 11 centimeter length was used to measure the shear strength of soft clay. A torque of 600 kg centimeter was required to shear the soil. Assuming the shear stress distribution at top and bottom to be uniformly varying from 0 at the center to the 0 at the center of the vane to the maximum at the ends, the shear strength of soil will be. The shear strength of soil will be. By reading the question, just let me know first, the stress distribution, it is uniform or the stress distribution, it is triangular. Which case will be applicable here? In this particular question, your stress distribution, it is uniform or it is triangular? Just let me know by just seeing the data. Just let me know. Your stress distribution, it is uniform or it is varying? Yes, Prashant. It is saying that it is varying, right? It is uniformly varying. 0 at the center. Let's suppose this is the particular vane. If these are the particular veins, right? So it is varying like this. So it is maximum at the ends and it is 0 at the center. Clear? So which formula will be applicable? Which formula will be applicable? Your formula which will be applicable is tau at failure, it will be is equal to T upon pi d square h by 2 plus d by 8 plus d by 8, right? Just give me the answer. We need to find out the answer in kg per centimeter square. Put the value of diameter in centimeters or length value in centimeters, torque value in kg centimeter. There is no need to change the units. Just calculate and give me the answer. Just calculate and give me the answer. There is no need to change the units. Height is given to you height is given to you 11 centimeter, diameter is given to you 7.5 centimeter. Just put the values in the formula and give me the answer. 0.53 kg per centimeter square. Everyone is getting the same answer. Everyone is getting the same answer, 0.53 kg per centimeter square. Yes, that is the correct answer, right? Now next we will move to the application part of soil mechanics. Up to this particular part we have discussed about the soil mechanics. Now it is the part where you have to apply the concept of soil mechanics, right? So in that particular case we are going to discuss about this particular concept of earth pressure in any particular wall, right? What will be the lateral earth pressure due to any particular soil? This particular concept mainly used for the design of retaining walls. Let's suppose there is a particular retaining wall, right? I'll just explain you some of the concepts. Let's suppose this is particular retaining wall, or this is the retaining structure. So what is the work of this retaining structure? The work of this retaining structure is to retain this particular soil, right? So let's suppose this is your soil. We call this particular soil as a backfill. So this is your retaining structure. Clear? It can be retaining wall, it can be sheet pile wall, anything. Clear? This is particularly this particular soil, we call it as a backfill. We call it as a backfill. If this particular wall, it is holding this particular soil, it will apply a pressure on this wall in the lateral direction, right? So this is nothing but your earth pressure. I'll call it as a sigma horizontal, right? And this sigma horizontal, it is the function of your vertical stress, sigma V. So your sigma horizontal, it is nothing but is equal to K times your sigma vertical. It is the function of your vertical stress. The calculation of this vertical stresses we have already done in effective stress chapter. How to calculate the vertical stress at any particular point, that is known to me from that particular effective stress chapter. Now here we have to apply this particular concept, right? Now in this particular case we are having three cases, right? It is just for the revision. I am just giving you. Once, if your wall is unyielding, it means due to this particular pressure your wall is not moving, this wall is at rest. If it is at rest, right? So our K value will be is equal to K naught. Clear? Your sigma horizontal, it will be is equal to K naught into sigma vertical. K naught into sigma vertical. Here this K naught we call it as a earth pressure coefficient in case of rest condition, which is given by 1 minus sin phi. This is one empirical relation. Also it is given as mu upon 1 minus mu. Mu upon 1 minus mu. Clear? We know that the maximum value of mu, it can reach to 0.5. That is also in the ideal condition, right? It means this mu value, it will be less than 0.5 only. So if you find out the ratio of K naught, it means it will be always less than 1, right? If K naught value is less than 1, can I say that my sigma horizontal, it will be less than sigma vertical? So at rest, my sigma horizontal, it will be less than my sigma vertical value. It will be less than my sigma vertical value. Clear? From here also you can see it is 1 minus sin phi. Now phi value will be 1 at 90 degree. There is no particular type of soil in which your friction angle will be 90. Clear? It means this particular value, it cannot be 0, your phi value, it will be 0, and that in that particular case this k naught will be 1 only. Clear? So it will be your sigma horizontal, it will be less than or it can be equal when your soil is purely cohesive. Clear? Now if your wall is moving away from the backfill, some of the pressure will get released. It means your horizontal stress value, it is going to get decreased. Your sigma vertical is constant, your sigma horizontal get decreased, right? So second condition, when wall is moving away from the backfill, that will be your active condition. In this particular case also, my sigma horizontal, now it become more or less. My sigma horizontal, it will be less than sigma vertical, right? Also I know that sigma horizontal, it is the function of sigma vertical. Now this coefficient I am calling it as Ka. So this Ka is your active earth pressure coefficient given as 1 minus sin phi upon 1 plus sin phi. Clear? One more condition, that is condition of passive condition. If this wall is moving towards the backfill, if you are pressing this particular soil with the wall, that soil, it will increase its pressure over this, right? It means in this particular case your pressure value, it is going to get increased in terms of this, right? So there will be one passive case when wall is moving towards the backfill. In this particular case, your sigma vertical, it will be greater than sigma horizontal. That you can see from the formula also. Your sigma horizontal, it will be, if I am talking about passive condition, I am using this Kp value into sigma vertical, right? Sorry, your sigma horizontal, it will be greater than sigma vertical, right? So this is your sigma horizontal, this is your sigma vertical. What is this Kp value? This Kp value is your 1 plus sin phi upon 1 minus sin phi upon 1 minus sin phi. Clear? Now from this particular chapter, two type of question are asked to you. One is to calculate the earth pressure value. In any particular case, it can ask for the active case, it can ask for the passive case, it can ask for the rest case. So one is calculation of pressure value. Its unit will be what? Its unit will be, let's suppose force is in kilonewton, so it will be kilonewton per meter square. Second, it can ask for what will be the thrust or what will be the force applied by this total soil on this wall. This pressure value, it will be different for different depth. At particular depth, it will be different. At this base, this pressure value will be different. But due to this whole backfill, what will be the force applied on this wall, right? That we call it as a thrust, right? And this thrust value, it can be asked for active case, for passive case, or any particular value, right? For the rest case also. So simply, what will be the thrust? Thrust will be your area of pressure distribution diagram. Thrust will be the area of your pressure distribution diagram. So simply draw the pressure distribution diagram. What is the different pressure value which is changing with the depth? The area of that pressure distribution diagram, it will give you the thrust value. Clear? I hope all these concepts you have already studied, right? Just I have given you the insight of this particular concept also, right? Now try to find out this particular question. Try to find out this particular question. This is from your earth pressure value, you need to find out in the cohesive soil, right? So I have taken the most generalized case. In this particular case, our both the concept, when there will be formation of tension crack and when there is no tension crack, it will be clear. It will be clear by this particular question, right? So as we are running out of time, I'll just explain this particular question to you. You can also try this by that particular time. What it says, a rigid smooth retaining wall of height 7 meter with vertical back face retains saturated clay as backfill. The saturated unit weight and undrained cohesion of the backfill are 17.2 and 20 kilopascal. The difference in the active lateral force it is asking for the force value on the wall in kilonewton per meter. You can remember this unit, kilonewton per meter, right? Up to 2 decimal places before and after occurrence of tension crack. Before and after occurrence of tension crack. Clear? So this is the particular question. It is also asked in your GATE previous year, right? But this is the particular generalized question in which you will get the idea that what will happen before tension crack and what will happen after tension crack, right? So I'll just explain this concept also. Let's suppose this is your particular wall. This is your retaining wall. It is having this backfill. This is having a backfill, right? Now we know that in case of cohesion, what will be your sigma horizontal value? That is earth pressure value. I am writing it as for active condition PA. It will be what? It will be K into sigma vertical minus 2c under root of K. Now this particular formula also derived from that GATE equation only, right? This particular formula you got from the GATE equation only. When you will put, as this is the active case, my sigma horizontal will be sigma 3. As sigma horizontal is less, my sigma vertical will be what? My sigma vertical will be sigma 1. So if you will put sigma 1 as sigma vertical, sigma 3 as sigma horizontal, you will get this particular relation. Clear? Where this K is nothing but 1 minus sin phi upon 1 plus sin phi. Or you can also call it as, in that particular equation, you will get this particular term as 1 upon tan square 45 plus 5 by 2. If you remember that GATE equation, in that GATE equation, 1 upon tan square 45 plus 5 by 2 is nothing but 1 minus sin phi upon 1 plus sin phi. Clear? Now, if I use this particular equation, right, first I am taking the case of no tension crack. No tension crack. So if there is no tension crack, what will be my pressure distribution? My pressure distribution at this particular point, the sigma vertical will be 0 at top. It means this term will be 0. It means there will be a negative pressure. I am representing in this direction the negative pressure. So my stress distribution will be something like this, right? So this is negative pressure. It means this is your tension and this is your mainly compression. This particular height up to which there will be a tension zone, we call it as a depth of tension crack, right? Due to this particular tension zone only, there will be a generation of tension crack. But if there is no tension crack now, you will get this particular zone, and this ZC it is given by 2c upon gamma under root of K. 2c upon gamma under root of K. At same depth ZC, again there will be same value. This is negative, this is positive. It means this negative and positive area, they get cancelled out. So if I want to find out what will be the force in this wall, I can use the area of this stress diagram, right? What was this particular value? It was for minus 2c under root of K. This will be your plus 2c under root of K. What will be this base width? This base width will be what? This base width is gamma into K into sigma vertical. This will be your K into sigma vertical minus 2c under root of K. Minus 2c under root of K. So area of this trapezoid, it is going to give me the force value, right? For calculation of area, I will need this particular depth also. This particular, it is your 2 times of ZC. We call it as sometime depth of unsupported cut, HC value, right? As up to this particular depth, there will be no pressure on this wall. As this particular pressure and pressure, negative and positive pressure, it will get cancelled out. So there will be no force on this wall, right? So we call it as a depth of unsupported cut. So I can say that this particular depth remaining is, if it is H, now it is H minus 2 times of ZC. Clear? So we need to find out these values now. Now try to see what is the data given to me. For calculation of K, I will need phi value. I will need phi value. What is the phi value? Phi value is not given to me. It is given as, this is the clay. It means phi value is 0. Phi value is 0 means K value is 1. K value is 1, right? Second is gamma value is known to me, that is 17.2. Height of wall is given to me 7 meter. Now I am writing those values in this particular. This is your 7 meter, right? Gamma value is also known to me. What is gamma value? Your gamma value, it is given as 17.2. Gamma value is given as 17.2. Where this gamma value will be needed? Once this gamma value, it will be needed for the calculation of your ZC. I think cohesion value is also known to you. That is 20 kilopascal. That is 20 kilopascal. Right? So this data is given. So you can find out the ZC value. So ZC value, it is 2C upon gamma under root of K. C value is known to you, gamma is known to you, K is known to you. I'll just write this particular final value. So I am getting this particular final value as, if you have calculated, you can also give me the answer. If you have calculated, you can give me the answer. So ZC I am getting. ZC I am getting. I'll just write the data now here. What are the data I am obtaining? ZC I got as, it is 2C upon gamma under root of K. So ZC I am getting 2.325 meter. So HC value will be what? HC value is your, HC I am getting it as 4.65 meter. Just check with your calculations. HC I am getting it as 4.65 meter. Right? Now, I can calculate this value 2C upon under root of K. This 2C upon under root of K, I am getting it as 40. And K into sigma vertical, it will be, sigma vertical is gamma into H, gamma into this height. Height is known to me 7, K is known to me, cohesion value is known to me. I am getting this particular value as 80.4. 80.4, right? So this value is known to me 40, this value is known to me 80.4. This particular value, H minus 2 times of ZC, that is HC value only. HC value we got it as 4.65 meter. So 7 minus 4.65 meter, this will be your what? 2.35. 2.35. Now give me the area of this particular trapezoid. First, give me the area of this trapezoid which is having the top width as 40, bottom width as 80.4 and height as 2.35 and height as 2.35. Just give me the value. Just give me the value. This value will be what? This value will be your area, that is earth pressure force. For no tension crack, it will be half sum of parallel sides. Parallel side is 40 plus 80.4 into this distance, that is 2.35. That is 2.35. I am getting it as 141.47. 141.47 kilonewton per meter. Kilonewton per meter. Just check if you are getting the same answer or not. Just check if you are getting the same answer or not. 141.47. Yes, Prashant. Just let me know the case of no tension crack is clear or not. First, just let me know the case of no tension crack is known to you or not? Is it clear, everyone? Then we can proceed to next case when there will be a tension crack. When there will be a tension crack, just let me know in the chat box if this particular concept of no tension crack is clear or not. Tell me. Okay. Now what will happen if there will be a tension crack? What will happen if there will be a tension crack? If there will be a tension crack, now I'll draw the diagram here so that you'll be able to compare these two. Now if there is a tension crack, it means up to this ZC height there will be a tension crack developed, right? Up to this height a tension crack get developed. It means this particular soil, it loses its contact with the wall. So due to this particular soil there will be no pressure, only this pressure will be there. So it is 0 here, this particular depth is ZC, right? And this is your stress value now. Now the area of this particular stress diagram, it will give you the earth pressure force. This is the second case of tension crack. Tension crack. This is the particular area. This is the particular area for which you will get the stress value. So PA will be what? This base you already know, it is 10.4. What will be this height? This height will be 7 minus ZC, that is 2.325. So this particular height I am getting it as 4.675. 4.675 meter. So what will be PA value? Area of this, that is half, it is triangle. Base into height, base is your 80.4 into height. What is the height? 4.675. 4.675. If you will solve this particular, you are going to get 187.935 kilonewton per meter. Kilonewton per meter. It means what is the increase in effective stress? What is the change in stress? Sorry, what is the change in this earth pressure force value? What is the change in earth pressure force value? It will be 187.935 minus 141.47. What will be the value? What is the change? Can you tell me? 46.5. 46.5. I will also check if I am getting the same answer or not. Yes, it is 46.5. It is 46.5 kilonewton per meter. Right? Now I will give you one more approach. This is the particular approach I have just shown here so that it will be clear to you what are the changes when there is no tension crack and when there is a tension crack. But if you are solving this particular question in exam, you have to be very smart. Now here you can use your aptitude. If you see these two diagrams, can I say the change in these two diagrams is only this particular top part? The only difference in these two diagrams is this particular top part, right? This particular triangle. If I draw it separately, this particular triangle, it is the only change, which is having a height of ZC, and this top width is minus 2c under root of k, which was, we have calculated it as 40. We have calculated it as a 40, right? ZC value we have already calculated. ZC value is 2.325. 2.325. We need to find out the change. So this is the only change. This is the only change between these two diagrams, right? When there was no tension crack and when there is a tension crack. So if I calculate this particular area, it means this is the earth pressure force value which get changed. Now just calculate the area of this particular triangle. If you will calculate the area of triangle, as I am talking about the change, there is no point of taking the negative sign. So it will be half base, that is 40, into height, that is 2.325. Can you give me the answer? Can you give me the answer now? What is the area of this particular triangle? Are you getting the same as 46.5 or not? Are you getting it answer as 46.7, 46.5 or not? That is kilonewton per meter. So in exam you have to think like this only, right? So if you proceed with this type of process, right, it will be very lengthy. But there was no need to do all these things. I have just explained it to you so that you will be able to see what is the difference between no tension crack and tension crack problem. Otherwise, if I need to find out what will be the change, I can see that this particular earth pressure diagram is only the change. So the force due to this particular, it will be a change. So I have calculated the force due to that particular pressure distribution, right? So your correct answer will be 46.5. Is it clear? Is it clear? Right, so what will be this particular value? 46.5. This kilonewton per meter of the length. Kilonewton per meter of the length. Right? Okay. Now this is one problem from your stability of slopes. From the stability of slopes. Now this is your MSQ type of question. It means more than one option can be correct. This is your MSQ type of question. More than one option can be correct. It is saying that for the trial slip circle shown in figure, you can take this circle. Right, this is your trial slip circle. For the trial slip circle shown in the figure having a weight as 280 kilonewton. Unit weight of soil is 18.7 kilonewton per meter cube. Pi value is 0. Cohesion value is given to 27 kilonewton per meter square. Select the options which is or are correct for the slope shown in figure. It is asking for the value of restoring moment, the value of sliding moment, and the value of factor of safety. And the value of factor of safety. Just let me know the correct answer. I know that if this particular is your failure slip circle, this particular soil, it is going to get slide in this particular direction. If this particular soil having this particular slip circle, this particular soil due to its own weight, it is going to slide in this particular direction, and it is sliding with this as a center. It is sliding with this as a center. It means the destabilizing force for this particular soil, it is this weight of this particular failure wedge. It is the weight of this particular failure wedge. Clear? And what is the restoring force? Which particular force it will be responsible, or which particular moment it will be responsible to restore this particular soil? That is the cohesion at this particular way. That is the cohesion between the particle at this particular failure plane. Clear? This particular cohesion, it will be acting along this particular failure plane, right? So if I talk about the restoring moment, what will be the restoring moment? That will be the force along this. Force will be what? Force will be your cohesion multiplied by area. If I take the length of slope perpendicular to this screen as unity, so it will be length 1 into this length of this slope. What will be the length of slope? This is nothing but a part of arc of the circle, right? We know that the total circumference, it will be what? It will be 2 pi r, right? So 2 pi r is for the 360 degree. 2 pi r is for the 360 degree. I need to find out for 107. Can I say it will be 2 pi r into 107 upon 360 degree? This will be the length of slope, or this length of the failure wedge. This is now my force. Multiply by the perpendicular distance. It will give me the moment. that is R value. That is R value. Now radius is known to you, cohesion value is known to you. Just check if you are getting it as 3643 or not. Just check if you are getting it as 3643 or not. Prashant, Amit, Kanu, Himanshu. Just check if you are getting it as 3643 or not. Cohesion value is known to you 27. Radius is given to you 8.5. Right. So you are calculating the restoring moment about this particular origin of the circle, center of the circle. Just give me the answer if you are getting it or not. Prashant. 3641. 3641.18. Okay. Right. If you will take the exact value, it will be approximately this value only. 3643. This will be 3643. Clear? So it means this particular statement is correct. It means this particular statement is correct. If you will not assume any particular pi value as, if you will write it as pi only, if you will do it with the calculator, right, you might have approximated pi value as 3.14. So you will be getting some deviation. Otherwise, this 3643 you will get. Clear? Now, second option, the value of sliding moment is 2090. What caused the sliding? I know that the sliding, it is caused due to this weight. So what is the moment due to this particular weight about this center? This is the weight or force multiplied by this lever arm. So this is nothing but W into, if I take it as x bar, W into x bar, W value is given to me, that is 380. X bar is given to me 5.5. Just check if you are getting it or not. What is the sliding moment you are getting? Yes, what is the sliding moment you are getting? Just let me know. What is the sliding moment? So you will be getting it as 380 into 5.5, 2090 only. 2090. It means this particular statement is also correct. Right? 2090. What will be the factor of safety? I know that factor of safety, it is the restoring moment by sliding moment. Restoring moment was my 3643 upon sliding moment 2090. So you will get the factor of safety as 1.743. You will get the factor of safety as 1.743. Clear? It means this particular option number C is also correct. So what will be the correct answer? Your option number A, option number B and option number C, all you have to mark to get the 2 marks, right? So if it is a 2 marks question, to get those 2 marks, you have to answer all the 3, A, B and C, all 3 options you have to choose, right? This is particularly your MSQ type of question. It means more than one option you can select and more than one option can be correct. Clear this thing? Now this particular part of shear strength of soil and the stability of slopes. In stability of slope, you can also go for that infinite slopes also, right? So that infinite slope is also important. There are only 3 cases for the calculation of factor of safety. One is the case of dry soil, second is your case of submerged soil, right? And third is your case of that soil in which there is a seepage, right? And in that seepage also you are having 2 conditions, when the seepage is below the ground level, and one is the condition when the seepage is at ground level. Clear? So formula for all the 3 conditions, it should be known to you how to calculate the factor of safety. So mainly factor of safety, it will ask you in the question. Other than that, there is one method, that is stability number, Sn is equal to C upon gamma into Hc. That particular concept, it can also be asked. So just remember that particular formula also, right? I have just chosen that what are the most probable question which can be asked. So this is what we have discussed, but there are other important points in that stability of slopes. Now if we move to the foundation engineering, right, that is the mainly part which we need to discuss. Soil mechanics we have just discussed, so that we will be able to understand that okay, how my soil it is going to get behave when there will be loading over this. As we are constructing any superstructure, due to that superstructure there will be loading on the soil, right? Due to that particular loading, how my soil is going to get behave, that is what we have studied in our soil mechanics. Once now the behavior is known to me, now I can design my foundation and I can see that okay, if that particular soil it will be able to bear the load which is coming on the foundation or not, right? So here are some terms. First, it should be known to you. These are some important points. By now, if there is any doubt, you can just type in the comment box. Otherwise, we can proceed. If you feel there is any doubt, just let me know in the comment box. After that, we are just going to discuss. I'll just discuss some of the basics of the foundation engineering. What are the important parts? It is not like the full class, right? The main agenda is to solve the questions. But just I will give you some input that what is the particular important part in this chapter. Clear? Now, if you are starting with the foundation engineering, these are some terms which should be known to you. One is gross pressure. Now just listen it just in a quick way, right? Let's suppose this is my particular foundation, right? Now the foundation will be below the ground level. It will be below the ground level. Now due to this weight of soil, this is my soil, this is column and foundation, and this is the superstructure load. Whatever is the pressure acting at the base of the foundation, due to this superstructure load, due to the weight of the foundation, due to this soil, that we are calling it as a gross pressure intensity. Clear? So whatever is the pressure at this point, due to all these factors, that is superstructure load, due to this weight of the soil, due to the weight of this foundation, that is my gross pressure intensity, right? Now if I talk about this particular stress value at this point, can I say that the stress value which was due to the weight of soil, the stress value which is due to the weight of soil, it was at this particular point even before construction of our structure. The weight due to the foundation, the weight due to superstructure, it came into effect after we have done the construction. But this weight of soil, it was there even before the construction, right? So if I don't take that particular stress value into account, that will be my net pressure value. So what is the net pressure value? It is the gross pressure minus the pressure which was due to this particular soil. So if df is the depth of foundation, if df is the depth of foundation, what will be my q net value? It will be q minus the pressure due to this soil. What will be the pressure due to soil? We know it will be gamma of soil multiplied by depth of foundation. Gamma of soil multiplied by depth of foundation. Clear? So we have just removed the pressure of soil from this particular total pressure value. So we got the net pressure. Clear? Now this pressure value, it can also be greater than the strength or the pressure which your soil can carry. This pressure can also be greater than the pressure which your soil can carry. If I want to find out what is the maximum pressure, my soil can bear without failure, what is the maximum pressure value which my soil can bear without pressure, that particular value you will call it as a ultimate bearing capacity. Ultimate bearing capacity. Clear? Let's suppose if your soil can only take 50 kilopascal load or 50 kilopascal pressure, but if you are constructing a building, you can construct it for 5-story, 10-story. Let's suppose due to that 10-story, the pressure over your soil, it is 700 kilopascal. Your strength of soil was 500 kilopascal, but you have made on building which is having a pressure of 700 kilopascal, right? So your gross pressure will be 700 kilopascal. Under that loading, your soil is definitely going to get fail. But if I talk about the bearing, ultimate bearing pressure or ultimate bearing capacity, it is that particular stress value at which, or it is the maximum stress value which your soil can bear. Clear? So this is the ultimate bearing capacity. We represent it with QU. What is the net ultimate bearing capacity? Again, out of this ultimate bearing capacity, if you subtract the weight of the soil, it will give you the net value. It will give you the net value, right? There are some more definitions. One is net safe bearing capacity. What is net safe bearing capacity? If you know the net bearing capacity, if you divide it with factor of safety, it will give you the net safe bearing capacity, right? Why we are calculating this? Let's suppose your soil can bear the maximum stress value of 50 kilopascal. It is not like that you will load that particular soil up to 50 kilopascal only. You will take some factor of safety. You will only load it to 40 kilopascal or 30 kilopascal, so that if there will be some increment in the stress value in future, it will not get failed, right? So just for the factor of safety, what you have done, you just apply a factor of safety on this particular value, so that you will get one pressure value which is net safe. Clear? Another is safe bearing capacity. Safe bearing capacity. Your safe bearing capacity is nothing but net safe bearing capacity plus gamma df. We are not calling it as, we are not calling safe bearing capacity at ultimate bearing capacity of factor of safety. It is not correct. It is not correct. We know that Q is nothing but equal to Q net safe plus gamma into df upon factor of safety, right? Upon factor of safety, sorry, Q net plus gamma into df, right? So here see, if you will write this particular formula as this, your gamma df also is divided by factor of safety. It means you have applied the factor of safety on this stress value which was coming due to the soil. As this particular stress value, it was even in the past also, we are not concerned about this particular value, right? So we don't apply the factor of safety on this gamma df value. So first apply the factor of safety on net value, that will be QNS, then add this gamma df. It will give you the safe bearing capacity of soil. It will give you the safe bearing capacity of soil. Clear? Now to calculate the bearing capacity of soil, we have different formula. One given by Terzaghi, that is Q at failure, it is CNC into gamma into df into NQ plus half gamma B N gamma, right? Here D is the depth of foundation. It is depth of foundation, and B is the width of foundation. B is the width of foundation. Now remember this particular formula, it is only applicable for strip footing. It is only applicable for strip footing, that particular footing which is having a length very much greater than its other dimension or its width, right? Just like if you see a wall, that wall, if we made one foundation below wall, its width will be less, but its length will be whole along the wall, right? So that particular type of foundation we call it as a strip foundation. So whenever there is a high length, when the length is more than, or when your length is so much greater than your width or in comparison to your width, we generally do the analysis for unit length. Clear? So we take the length as 1 and we only do the analysis on the basis of width. Clear? So this particular formula, it is only valid for strip footing. This is given by your Terzaghi. If we talk about NC, NQ and N gamma, they are the factor of your friction angle value, that is phi value. These all values will be given to you by the examiner only, right? But for one standard case, when your phi value is equal to 0, for this at least you can remember the values. If your phi value is 0, your NC value, it will be 5.7, your NQ value will be 1, and your N gamma will be is equal to 0, right? For other phi values, you don't need to remember the formulas, just it will be given to you by the examiner. Only in the case when their phi is 0, when the soil is cohesionless, when the soil is purely cohesive, in that particular case, you will need this particular data, that 5.7, NC is 5.7, NQ is 1, N gamma is 0. Also one assumption which Terzaghi has taken while driving this particular formula or while giving this particular formula, it was that it is valid for your general shear failure. It is valid for your general shear failure, right? Now, yeah, thank you Gopal sir, right? So it is only valid for your general shear failure. If there is local shear failure in soil, you have to use this modified cohesion value and modified friction angle value. Modified cohesion value and modified friction angle value. Where this modified cohesion value will be used in case of C. Where this modified friction value will be used, we know that this NC, NQ and gamma, they are the function of this phi, right? So instead of calculating NC, NQ, gamma for phi value, you have to use the NC, NQ, gamma value corresponding to this phi m. Clear? Next, for any other type of footing, the calculation of bearing capacity, it will be done based on these formulas, right? So if your footing is square, this will be the formula. If your footing is circular, this will be the particular formula. If your footing is rectangular, this will be the formula, right? So you can remember it like that. There is the only change, that is 0.4 and 1.3. So 1.3 you have to remember, it will be in every case. 0.4 and 0.3, mainly these are two values in which student get confused, right? So you can remember it like this. It is just a trick to remember. Here it is square footing. You know that 4 is the square of 2, right? So from square you can remember that, okay, it is 4. Other than that, there is a circular footing. Definitely for it will be 0.3. It is like that. For a strip it is 0.5, for square it is 0.4, and for circular it is 0.3. Clear? Also you can remember this rectangular footing value. Whenever you will write this rectangular footing value, at any particular point, if you feel confusion that, okay, I have written this particular formula correct or not, just put B is equal to L. Just put B is equal to L. If your B is equal to L, it means this particular formula, it should come in this particular form. That is the form of a square, right? So this is just the way where you can check that if you have written the particular formula correct or not during the exam. Clear? Now focus on the questions. Our main focus will be in questions, right? Other than that, there are some important topics in this particular chapter also, like plate load test. You should remember, right? Yes, Scampton method is also important. You can just remember the formula, right? You can just remember the formula from the Scampton test, right? I have just mentioned whatever is the most important part, right? It is not like that other things are not important. Those things are also important, but we need to cover this in particular 3 hours, right? So it is better that we will focus on the most important part, as main is the questions which we need to practice. Other than that, I am just telling you what is the other important parts. Your Scampton theory is important, right? You can remember just formula from that. You can also remember what is the particular formula for your Meierhof theory, right? Plate load test, those plate load test data also you can remember, right? There are some formulas for calculation of your bearing capacity and settlement on the basis of plate load test, that you should remember. Other than that, there is one field test for the calculation of bearing capacity, that is your standard penetration test. So in standard penetration test, you can remember the corrections, right? How to calculate? We know that the number of blows required for last 300 mm penetration, that is our SPT value. But more than that, the important part is the correction, that is dilatancy correction, and that stress correction which you apply, or overburden correction you can say, that should be known to you, right? So those are the just formula based analysis that you can remember. Here is the particular question which will be little conceptual. Just read the question and give me the answer. Just read the question and give me the answer. If you know the concept, you will be able to find out, right? This particular concept we have not discussed yet in this particular session, but if you have studied this, you will be able to answer. If you have studied, you will be able to answer. just by reading the question you will be able to answer. I have just give you the hint. By just reading the question, if your concept is clear, you will be able to answer. It is 200. It is 200. Okay. What this question says, two circular footing of diameter d1 and d2 are resting on a purely cohesive soil. The ratio of d1 and d2 is 2. If the ultimate bearing capacity of footing having diameter d1 is 200 kilonewton per meter cube per meter square, then the ultimate bearing capacity of footing having diameter d2 will be. We know that in purely cohesive soil, your ultimate bearing capacity, it is independent of the size of footing. It is independent of the size of footing. So whatever is the size of footing, your ultimate bearing capacity, it is not going to get changed. It is not going to get changed. So if for diameter d1 it was 200, still it will be 200. Still it will be 200. Clear? So remember this concept. For your purely cohesive soil, your ultimate bearing capacity, it is independent of the size of the footing, right? Now try this particular question. What this question says, I'll just explain to you. Determine the ultimate bearing capacity of a strip footing. Mark the important points. Strip footing, okay. Now we know which formula we have to use. 2.5 meter in the width. B value is given to you. Right, I'll also write the data so that later on it will be easy. Width is your 2.5 meter. At its base and its depth is 2 meter. Depth of foundation is given. That is 2 meter. Below the ground surface and resting on a saturated soil with the properties. It is resting on saturated soil. Gamma saturated is given to you. Cohesion value is given to you. Phi value is given to you. Related to this phi, NC, NQ, N gamma is value given to you. Also, the water table is given to you, not natural water table. It at 1 meter depth below the ground level. So if I draw this particular situation, let's suppose this is the ground level. This is my footing. Right? This is the depth of footing. Depth of footing is 2 meter. Water table is 1 meter below the ground level. It means somewhere here there is a water table. Somewhere here it is a water table. Right? So this is 1 meter. This is also 1 meter. That's why it is 2 meter. Right? It is asking for the bearing capacity. Value. We know that the influence zone of soil, the influence zone of loading which is coming on this particular foundation, it will get distributed within this B distance only, where the B is the width of the foundation. Yes or no? Right? Whatever is the load, it will have its influence up to maximum. This height or this depth is equal to the width of the foundation. This we take as a zone of influence, right? Below this there will be no influence of the loading on this particular foundation, or there will be no influence of the particular stress value over this particular soil below this particular length. That will be equal to width. Clear? Now try to understand. We know which formula we have to use. So we know that QU is equal to CNC plus NQ into gamma into DF plus half gamma B and gamma. Right? Now there are 3 zones. If this is the foundation, this is your depth of foundation, this is the ground level. So from ground level to this there is one zone, there is one zone. From this particular depth base of the footing up to this B value, there is another zone, right? Now try to understand this particular gamma into df, this particular gamma into df, it represents the soil of this particular portion. It represents the soil of this particular portion. It represents the soil of this particular portion. Whereas this particular parameter, it take into account this particular zone of soil. This particular zone of soil. Clear? This particular zone of soil. Right? It means, can you tell me what will be the gamma value here? What will be the gamma value at this particular point if water table is here? If water table is here, what will be the gamma value in this particular zone? Let's suppose this is term number 3, this is term number 2. I am taking it as zone number 3, zone number 2. Can you tell me what will be the gamma value in zone number 3? It will be saturated or submerged or any other particular value. Saturated, submerged or any other value. Tell me, for zone number 3, zone number 3 is from the base of the foundation up to the B width. It will be submerged. So now it is known to me that this gamma value, it is going to be gamma submerged. It is going to be gamma submerged. What about this particular soil for zone number 2? Zone number 2 is up to this particular depth. I know that this top soil, it is saturated, but this bottom soil, it is submerged, right? So below water table your soil is submerged. Above water table, it is said that the total soil is saturated. But above water table, if this soil is saturated, you have to consider it as gamma saturated only. But below water table, it will be submerged. For zone number 2, what will be gamma value then? You have to calculate it as gamma average. You have to calculate it as gamma average. As here it is gamma saturated for 1 meter, plus here in the second part it is gamma submerged, right, divided by total depth 2. So what is gamma saturated given to you? It is given as 20. Gamma of water we can take 10, right? So gamma saturated is 20 into 1 plus gamma submerged will be gamma saturated minus gamma W. Gamma saturated is 20, gamma submerged if I take 10, so gamma submerged will also be 10 into 1 plus 2, that is 15. That is 15 kilonewton per meter cube, right? Rest is only you have to put the values now. So what will be your QU? It will be CNC. What is the cohesion value? 20. C into NC. What is NC value? NC value is given to you 37.2 plus NQ. NQ value is your 22.5 into gamma. Gamma will be, for this particular soil, it will be gamma average, that is 15 into depth of foundation, it is given as 2 plus half gamma B. Half gamma, for this particular zone, it will be gamma submerged, that is 10 into B. What was the B value? Width is given as 2.5 into N gamma. Into N gamma. N gamma is given as 19.9. Sorry, 19.7. N gamma is given as 19.7. So just let me know the answer. Just give me the answer for this particular calculation. I will also check that how much answer I am getting. You just let me know what is the particular answer for this particular question. How much answer you are getting? Yes, Prashant. Yeah, thank you, Saurabh sir. One 1665.25. 1665.25. kilonewton per meter square. 1665. We have option number C as 1665. Clear? So this is the most appropriate answer. Is this clear? How to take into account the effect of water table? Is that clear? You just need to understand the concept. What are the different terms in that particular formula? There is no need to understand any particular other method, right? It is not necessary to remember any other formula. Just remember that what are the different terms in that particular formula, which particular parameter represents which soil. So it will be definitely known to you then that at which particular value your gamma is going to get changed and at which particular value it is not going to change, right? So effect of water table will be what? Effect of water table will be only that your gamma value, that is unit weight of soil, it is going to get changed. Clear? So it will be clear to you that at which situation, at which zone your particular, at which particular zone your values are going to get changed. If it is clear, just let me know in the chat box, then we can move to next question. There is one question for your homework, right? This is from the Mirror of Theory. You can take it as a homework. And when I am giving it as a homework, you should solve this particular question. These all are the also important questions. All these are also your important questions. There is the question from Mirror of. Everything I have included it in. Eccentricity is also there, right? So just go through this particular question and whatever answer you are getting, just post that answer in the chat box or in the comment box later. I will give you the answer that if it is correct or not, right? So you can just take the screenshot if you want. I'll just be aside. If you want to take the screenshot, you can just take the screenshot. This is the particular question from your Mirror of method. This particular one question, it will be sufficient to boost your concept of the Mirror of Theory, right? Next. Now if we talk about the pile foundation, right? So in pile foundation mainly your question will be from the calculation of your ultimate load carrying capacity. How much load your pile can take without failure, that is your ultimate load carrying capacity. So calculation of that mainly asked in the exam, and it is different for your different type of soil. If your soil is cohesive, right? Let's suppose this is the particular pile below the ground having length L and diameter D. Also your pile can be of this shape, having the base as square, having the base dimension as B, and length of the pile is L. So mainly these are the two shapes which are generally used for your pile, right? So out of these two, any can be given to you. So for cohesive soil, if we say, so your load carrying capacity of pile, it will be due to this base resistance. If this pile is taking the load, that particular load, it will be transferred to the base. So from base you will get some resistance. Also there will be a side friction. From the side which will help to take that particular load. Clear? It means this QP, it is equal to end bearing resistance multiplied by this end bearing, it is generated at base. So area at base plus side friction resistance multiplied by area at side as it generated at the sides, right? Now this QEB, it is given as 9 into C, that is cohesion value, into AB plus this QSF, it is given as alpha C bar AS. What is this alpha? This alpha is your adhesion factor. Now remember that this alpha is coming into account as we know that if this is a pile, so this is a pile material, but here it is a soil. So at this particular interaction, there is one soil particle and at the side there is a pile material. So there is an interaction between soil and pile. When there is an interaction between soil and pile, there will be adhesion and not cohesion. there will be adhesion and not cohesion. If it will be an interaction between soil and soil, so in that case it will be cohesion, right? Now this alpha term, it coming into account to take this adhesion value. If there is a interaction between soil and soil, this alpha value will be 1, right? When there is a cohesion and not adhesion, this alpha value will be what? This alpha value will be 1, right? So this is to take into account of this adhesion, right? Now if we talk about area at base and area at sides, area at base and area at side, if your pile is your cylindrical pile, if the pile is cylindrical pile, right? So what will be the area at base? At base it is nothing but a circle having a diameter d, so area at base will be pi by 4 d square. What will be the area at side? That is nothing but the curved surface area, right? It will be pi into d, this multiply by length, so pi into d, that is the circumference multiply by this length, pi into d into length, that will be the area at side. So AB is pi by 4 d square, area at side is pi into d into L. Now if we talk about this particular case, if your foundation or if your pile is having a square at the base, so what will be the area at base? We know the area of a square, it is b square. And what will be the area at sides? Area at side will be the parameter multiplied by the length. So what will be parameter? That will be 4 times of b. This is b. So b plus b plus b plus b, 4b multiplied by the length of pile, multiplied by the length of pile, right? So these are the two formulas which are generally used for, these are the for the cohesion. What about if the soil is your cohesionless? For cohesionless soil, so if it is a cohesionless soil, your QUP will be NQ into gamma into depth of foundation. Here the depth of foundation is nothing but the length of pile, gamma into NQ into gamma into length of pile into area at base plus half K into gamma into L into 10 delta into area at side, right? So this is the particular value in case of cohesionless soil. This area of base and area of side, it will remain same. These are the particular values. This delta, again this delta is the friction angle made between the pile and soil material. This delta is the friction angle made between pile and soil material. If there is an interaction between soil and soil, this delta will be what? This delta will be phi. This delta will be what? This delta is going to be equal to phi value. I hope it is clear, right? Now if we talk about the group, so generally in group we are having the pile in the form of a square pattern. Let's suppose there is a pile group having the 9 pile, so it will be 3 cross 3, right? So whenever you are making the pile, it is not like a single pile you have installed. There will be group of piles, right? So how much load this pile group can take, that also you can calculate based on the same formulas. What you have to consider? Just you have to consider that these all pile as a bulk or as a block having this size of square pile. It is like the square pile only, right? And what will be this width? If this pile, this is second pile and this is third pile, if this is having a diameter d, and if center to center spacing, it is S, this center to center spacing is also S, right? So this is d by 2, this is d by 2. So can I say that this total width, it is 2S plus d? It will be 2S plus d. These are the 3 piles, then we got this particular formula. If there are n number of piles, so you can say it is nothing but n minus 1S plus d. When there is a pile in one particular line as n. Number of pile in a row, where n is what? Number of pile in a row. So you can find out what will be the b value. Clear? Also the one change will be what? When you are saying about this pile group, now when we talk about the interaction, there will be interaction between soil to soil. There will be interaction between soil to soil. So whenever you are calculating the load carrying capacity of pile, remember that your alpha value will be equal to 1 and your delta value will be equal to 5. This is the only concept you have to remember, as when you are talking about the group, right? So there is very less interaction between the pile and soil. There is mainly the interaction between soil and soil. There is mainly the interaction between soil and soil, right? So you have to use alpha value and delta value in the previous formulas. Otherwise, you can just do the same calculations. Clear? As we know that for the calculation, you will only need this particular area. So once B is known to me, by this, I can find out what will be the base area. It will be B square. What will be the side area? It will be 4 times of B multiplied by length of the footing. Clear? Based on this, this is the particular question. Again, I am putting this particular question for your homework. If you will find there is any particular doubt, right, either you can write me on the Telegram channel of official Telegram channel of IMS GATE Academy, right, there you can post. Otherwise, you can post in the comment box. I will give you what is the particular answer or what is the particular solution to this question, right? If it will be not clear to you, if you will not be able to find out this particular question, I will make one short video for that. Just if you will not get, just let me know in the comment box after solving this particular question, right? I'll just explain to you what this question says. Determine the spacing of a group of 16 pile with diameter of 300 mm, having the efficiency of pile group as 1. The pile were constructed in a uniform clay soil with unconfined compressive strength of 50 kilopascal. Now the hint I am giving you that for calculation of load carrying capacity, what are the values you will be needed? What are the values you are needed? You will need the cohesion value. Here unconfined compressive strength, it means UCS value is given to you, that is QU value. You know QU is equal to 2 times of C. From here cohesion you will get. Also efficiency is given to you. Efficiency is nothing but the load carrying capacity of group divided by the total load carrying capacity by individual pile. By the individual pile, right? So QUP you can calculate by using that particular formula. QUG also you can calculate using the previous analysis. But in QUG, when you will calculate the QUG, there will be one term which will be needed, that is the width of foundation, and that width of foundation will be what? As there are 16 piles, right? As there are 16 piles, it means one row. In one row there will be 4 piles. What will be this B? This B will be 3S plus diameter of single pile. And this S value is only unknown to you. This S value is only unknown to you. It is asking for that spacing between the pile. It is asking for that spacing between the pile. Clear? So you can just go through this particular question also. I have just given you what is the particular concept behind this question. You can just try and let me know if it is correct or not. Just take a screenshot. Just take the screenshot. Okay. So I hope you all have enjoyed the Geotech session number 1 and session number 2. These sessions will definitely help you to boost your score in this upcoming GATE 2023. Again, to every student, if you feel demotivated at this particular point, just think that why you have started this particular journey, and this particular thought, it will again boost you or motivate you to do your preparation up to the last day, right? By then, stay tuned with the channel. Thank you everyone. Happy learning.